Hello, good morning and welcome. My name is Rafał Motriuk. I'm a science and technology journalist and I'll be your host today in this room. Thank you so much for having me. This is Code Dive and it is now officially open. As you know, our city is famous for so many things, for its bridges, its rivers, its statues of little gnomes, including Nokia's own. It is also famous for its art, for its science and technology, but perhaps it is best known for its IT community, that is you guys. Welcome. I'd like to welcome everybody here today gathered in the New Horizons Cinema. It's so good to be back after the pandemic times, and I'd like to welcome everybody watching online. We streaming from all our 3 rooms, so shortly after the stream is going to split and our viewers online, you can choose which room you'd like to view. It is the 9th time that Nokia has organized this conference for us. Show of hands for whom this is number 9. Is there anyone who's been here from the start? Brilliant, brilliant. I can see some hands. Congratulations. Let me join you for coffee later. It's so good to be back. And over those 9 years, we've been through a lot. We've been through expansion. We've been through online versions only during the pandemic times. We've been pre-recorded, but now we are back and we are live. There are around 1,500 of us today here in the cinema. We have 3 rooms, over 20 speakers, so a lot to choose from. And some speakers are back. They've been here before. You know, we tried to keep them away, but we just couldn't. They liked it so much. Anyway, I think it's time for our first networking opportunity. So on my count, please, on 1, could you please say your first name? On 2, the name of your job, and on 3, number of years you've lived in Wrocław. So for me it would be 1, Rafał, 2, journalist, 3, 42, I'm sorry to say. Anyway, 1, 2, 3. Those who said 0, please stay with us. It's a very good place to live. Anyway, you know, such events can be very expensive, perhaps sometimes up to 1,000 euros each, but this conference is free. So I think it would be nice for us to put our hands together and thank our organizer and sponsor, Nokia. Very quickly, just some house rules. As ever, if I could ask everyone to please put your phones on silent. It would be great if you didn't interrupt the speakers until the Q&A session. And we doing it the old school way, so no fancy online stuff, just some mics in the room. Room capacity is slightly limited, but don't worry, all the talks are going to be recorded and you can view them later online on our website. There's a competition running, so in the meantime, if you're on a break or just changing rooms, try to find some white envelopes that are hidden here in the cinema. And once you find them, open them, read what's in them. There'll be a question, and if you know the answer, you can go to one of the publishers' house's stands, so PWN or Helios, and you'll get a reward. Also, don't forget about room 8, vintage retro games. I've already been there and I've already played, so there's pinball, there's Pong, and things that originated, you know, before a lot of us were even born. Lunch is at 1:25. There's no free food in this venue, but there are several places within walking distance, so you need to get your own food. If you'd like to stay, inexpensive coffee and snacks are in 3 stands, ground floor and second floor as well. And also there's an after party at Kontynuacja restaurant at 8:30. It's just around the corner, so everybody's welcome. And now I'd like to give the floor to Taras Lukaniuk, Nokia's Wrocław Technology Center head, and he's going to give his opening speech. Now, Taras unfortunately could not be with us this morning. He'll be coming later, so we have pre-recorded his speech. So Taras, over to you.
Good morning, code divers. I'd like to be friendly open with you. During previous years, when we were forced to do this conference online, as it was an only option to run this event, I was eagerly waiting for a year to finally see you all here in this cinema room and be able to welcome you in life. But tough luck, I cannot be with you right here, right now. I'll join a bit later. Anyway, a warm welcome to all of you, to speakers and listeners from Poland and from abroad, to organizers and to volunteers. A warm welcome to all who made this conference a very special day in a year, a day where the knowledge about latest cutting-edge technologies being shared, discussed, and respectfully challenged. I would like also to pass a huge thank you to a project team who was able to dive deeply into the code dive and made an excellent effort for this event to be at the top. In Nokia, we are creating technology that helps people to act together. For me, it simply means about staying connected. So use this opportunity. Expand your knowledge as well as expand your networking. These are both your superpowers. The 9th edition of Code Dive Conference is open. Enjoy every second of it.
Taras Lukaniuk. Now, it normally takes a year to organize Code Dive, but this year we have a brand new team of organizers, and they started working only in July. So they were working like crazy. The core team is 4 women, and they call themselves a patchwork project family. Now, you might call yourself patchwork, but for what we're seeing here today, the setup is just perfect, and it's very professional, so I'm sure everybody's going to be enjoying this conference today, given how well it is organized. So, who's the mysterious head of this new team? It's Eva Okołotowicz, and she'd like to introduce herself, the team, and the conference today. Eva, over to you.
Oh gosh, so many of you. Hello everyone, my name is Eva Okołotowicz and I'm External Coordinator in Nokia Technology Center in Wrocław. And I'm also a mother of this year's edition of Code Dive. Let me show you a very sentimental device to me. Who knows this computer? Who played Atari 65XE? You may raise a hand. Okay, you did. Oh, big fun. I see they did too. I may guess how old are you guys? Well, I did. I've played Atari like a maniac. You know, I played Builder Dash, River Red, Frogger, Montezuma's Revenge, and many, many more. Well, I always played second because of my older brother. The fights were fierce, you may imagine. Marcin, my brother, is watching us now, so I love you, and I hate the fact that I always played second and that you always played better. But thanks to my brother, we had a disk drive. And believe me, having a disk drive rather than tapes recorder, that meant like a true respect in the hood, right? But why am I mentioning that? Why did I bring it with me today? Maybe that's the fact that one of our dear speakers, Douglas Crockford, worked for Atari and released few quite known titles. Well, it might be, but I've brought it to you this time because this was like a game changer to me. That is a ticket to IT world. I remember first comments to change the background color. Wow, it was like a magic to me. Since then, I've always worked close to the technology, and I think that I always will. But I also believe that what is very important is both having knowing hard and soft skills. Maybe I did not become a programmer because my humanistic side had won, but I truly believe that to be the best version of ourselves, we need to have both soft and hard skills. And that is why we've enriched this year program with some predilections that are IT related, but also that touch the softer side of IT. So make sure you won't miss Agnieszka Szufarska, Natalia Lewków-Pankiewicz, or, that's right, Paweł Tkaczyk. No, that's not the end. Sorry, guys. So that's the ninth edition of a Code Dive, but the first one for me as an organizer. So let me thank you all for coming. Yeah, that's the most important for us. Many thanks to Nokia for such an amazing project, to the big boss, Taras, for trust and signing a budget. And huge thanks to my project team. And if you can believe, it consists of 3 wonderful ladies. Olga, Magdalena, Anya, thank you so much. Without you, I would have several heart attacks, that's for sure. Also, guys, one thing, remember to visit room number 8, because there is another true magic that we did there. We turned back the time to late 90s, and there is a retro, yeah, they call it retro now, retro games tournament with plenty awards to be won. And it doesn't matter if you're Atari, Commodore, or Pegasus team, you will find something for yourself. Okay, so remember, develop soft skills. Visit room number 8 for retro games tournament, and an official after party is in continuacja. Okay, Code Dive 2022, let's get started!
Brilliant, Eva. Thank you so much. Now, I've got a quick question before we start. If you can just yell your sound bites, when do you think it's the best time for the first technical malfunction during a conference? Now, yes, thank you very much indeed. Brilliant answers. Yes, so I'd like to welcome you to our first technical malfunction that we have now so swiftly dealt with, which only shows the professionalism of our team. So without further ado,
Okay, hello once again. Thank you for your patience. Welcome our online viewers too. We are in Wrocław in Kino Nowe Horyzonty, and it's time for our first speaker, Waqas Ahmad. Waqas Ahmad holds an MS degree in electrical engineering from Blekinge Institute of Technology in Sweden, with an emphasis on signal processing. He joined the MathWorks in 2019, and he works as an application engineer. His focus areas include C, C++, CUDA, code generation from Simulink, and MATLAB, fixed point implementation, and software deployment on embedded devices. Before joining the MathWorks, he worked for 7 years as an embedded software engineer at Alstom, in former Bombardier Transportation. Come here, Waqas, the stage is yours.
Thank you. Yes, thank you for the nice introduction. And my name is Waqas, and I am an application engineer at MathWorks. I work with workflows to generate optimized C and C++ code from MATLAB, Simulink models. Major concern is to deploy it on the embedded devices with low memory. And that's why I'm here today with this topic. Let's see. It's not visible here. Can we fix this? It's not connected yet. Perfect. Okay. Thank you. So that is why I'm here today with this topic, deploying neural networks onto an embedded device using pruning and quantization techniques. But before starting the presentation, can we see that who knows MATLAB and Simulink? Nice audience. And who is aware of AI in general, neural networks? And third is deployment onto the embedded devices as well. I see one hand, two maybe. Good. So it's the right audience for me. All right. So the main topic of this presentation is to deploy neural networks, not to just create or train the neural networks, to deploy neural networks onto embedded devices. And that is the main thing what we will be discussing in this presentation. Let's just move on. So you will be having a PC with any software. I'm here just writing MATLAB because I'm from MathWorks, so that's why. But from that, you train your network, you create your network, a neural network, and then you reduce the size of neural network in a way that you get the same or almost the same accuracy as it was original. But you reduce it, and then further you quantize some of the parameters. I will come to these every part. And then further, you generate C and C++ code and deploy it onto some hardware. And in this case, I will take example for Raspberry Pi. Embedded deployment is sometimes referred to as edge AI as well. So, and we see this trend is becoming more and more popular. AI is spreading out in different vast industries, and they are using multiple targets. But the targets, they are of course different. For example, the heavy industries or cars, they use microcontrollers. PLCs is in use in manufacturing. Wireless industries, mainly using FPGA or ASICs. And similarly, the low power devices or hearing aids, they are using ultra-low power chips. But one thing is common between these all hardwares is that these all hardware mostly have very little memory footprint. So you don't have the infinite memory to deploy anything onto the network, onto the end device or edge device. So this is one of the problem that we will address today. Second thing is that they are compute hungry, and we will not be focusing on compute hungry. Different like GPUs and FPGAs, they solve those problems easily, but they are compute hungry. And the third thing is, if you really want to deploy something onto the embedded hardware, you need specific programming skills as well for pre-processing and post-processing and modeling techniques. But why do we see these challenges in the first place? We see that AI and specific deep learning part of AI, it's mostly led by the research scientists in different industries. And honestly, I have never seen that they care about the end devices at all. they try to create very flexible and very impressive applications as much as possible. And that's why the networks come very big in the first place. And the second thing is that when they research, they are ending up into heavy parameterization into the networks. Maybe you have seen this example, DALI 2. It's a very cool application that you can write your text description, and according to the text description, there will be a couple of images generated using the AI models. Just for a reference, I have just placed one table here where we can see some of the famous neural networks here. And you see SqueezeNet, it's taking 5.2 megabytes of memory. And I will talk a lot about megabytes and bytes in this presentation. So 5.2 megabytes and having 1.24 million parameters. And if we see the same like VGG16, it takes 515 megabytes of memory. And of course, I mean, Raspberry Pi right nowadays, Raspberry Pi 4, the latest version, it has, I think, 4 GB RAM. And similarly, some advanced hardwares, but not all the low power devices. We cannot embed Raspberry Pi into everywhere. I mean, for the hearing aid, you cannot take Raspberry Pi into your pocket and working with that. So you have low power devices where your memory is in almost kilobytes. Quite expensive. So far I have been speaking about AI in general, but what they actually really are, if someone asks about that. Normally, if I just categorize them into parts, there are three main parts: input layer, hidden layers, and output layer. So whatever your problem is in your hand, for example, object detection or classification, you have something input. For example, in this case, I have an image with RGB, so I have 3 inputs. And then further, I have multiple layers. And every layer has its own working along with the training stuff, and they set their parameters according to that. And they do different things. For example, edge detection, color detection, object detection, these kind of things further, they train itself. And the output layer is the output required. Whatever you need from your network, you get the output layer according to that, and you will get the output. In this case, we have an image output as well, as same as the input layer. So typically, deep learning tasks are image classification and object detection, as I said. In the benchmarks for image classification, we often use a standardized data called ImageNet, which contains millions of images in thousands of different categories. And the network has this network, which I will show now. This network is already trained for a data set and is able to classify 1,000 different classes. Let's see just this in action, if this video can play. Yeah, see, we are moving the camera, the camera, and detection is going on the right side. You see the probability percentages. Mouse, it can be modem as well, but very low probability. Laptop or notebook, sunglasses. So these kind of object detections, and in the end, chainmail. By the way, chainmail, I just Googled before coming here. Chainmail is a type of armor made up with small rings. Okay. So with that small introduction to what neural networks are, let's look at the workflow that can be used when you want to compress a neural network. That don't fit onto your target, but you want to compress in a way that fits onto your target. But for that, you need to know your hardware, your target first, and the model you take as an example for deployment. So hardware constraints, of course, you need to, and then you need to select a model wisely. If you end up with VGG16, good luck to you. For Arduino, I would say. And similarly, then you simplify your model, quantize parameters. I'm talking this, I know I am talking these specific terms again and again, just to show you that, okay, this will be, in the end, you will get from this presentation. Quantize parameters and then deploy onto the target. But this part, selecting model and quantization and simplifying the model, this is iterative process. Just wanted to show you. This is not one end. So you select model, you simplify or reduce the memory size, quantize, and check the accuracy. If accuracy is not meeting with your criteria, then go again, fetch another model or change the parameter for simplification. Okay, so let's start with looking at model selection. As I mentioned, AI research has had the tendency to not care too much about the end hardware, and that they can therefore be quite bloated. In this chart, we can see on the y-axis the accuracy percentage and the x-axis relative prediction time. And the size of the circles shows the memory it takes. And if you just take the example for these two networks, mobile V2 and VGG16, you see almost the same accuracy percentage. But we can see that, okay, the smaller network can have the same accuracy and almost the same prediction time as well as compared to the large VGG16. So it's important that what you are selecting the model, that's good enough to start with. Further, if you look at simplifying the model, what we typically include here for deep neural networks is the process called pruning. So we have selected a model, now we are trying to simplify the model. So you have trained the model, you have a lot of different weights, and then there is a pruning process where the pruning process is a structured process where we evaluate the importance of the weights in a trained network. And if the importance of the weight is less than our threshold, some set threshold value, we discard those weights completely. So it means that those weights will be gone, and then we need to retrain that model. And after training and pruning, you have pruned, retrained network with lower weights compared to the original network you took. Then the next phase comes for the quantization of the model. And here you can see on the screen, deep network quantizer. I think I can, yeah, this one. So this is probably the last part of the compression. And when I say compression, okay, I know all people are technical here. Compression doesn't mean that I'm creating JPEG or compressing the images. I'm compressing the neural network itself. So reducing the memory size is equal to compression here. So last part before deployment is probably the quantization in this process, where you all the parameters trained in MATLAB, and I've seen in Python and different languages as well. Normally they are floating point, single precision. We take single precision as an example, and that is 32-bit memory size. But we also know that there is a fixed point implementation for floating point, and that can take int 8 bits. Of course, you will lose the precision a little bit, but that's a trade-off. You save a lot of memory there as well. But the process for conversion from floating point or single precision to fixed point, that's cumbersome. That's why normally people don't go there. And that's why this application or a toolbox called, in MathWorks, we have a toolbox called Fixed Point Designer, where you design. You have input as fixed floating point, single precision, or double precision. And then you have a whole process, where you see the accuracy and convert your model or code into fixed point. And this is one of the applications from that toolbox, which is known as deep network quantizer, and this is specifically for neural networks. So it takes the neural network as an input and quantize the parameters and return or export the parameters in int 8 format. Okay. So far, I have been speaking about compressing the train model, but to understand the most common use case of why we need to compress or reduce the memory size, we need to understand the networks we are training or we have trained. So in deep learning, there are two major types of training the network. One is to train a deep network from the scratch, where it takes a lot of resources, time, a lot of images to train, because it's not an easy job to train a network. If you have a lot of data, then you can train a very good network. Otherwise, you take a pre-trained network, like I've shown you in the table, a lot of different networks. They are pre-trained on different categories of images. For example, if you're talking about images, then for audio, there are different networks as well. And you take pre-trained network, and you fine-tune that network according to your need, whatever you want. And this process is called transfer learning. So you transfer learn, you are transferring the learning process from that model to your need. Okay, so what are these steps to do the transfer learning? The first is to load the pre-trained network. And the way a convolutional neural network typically is constructed is that early layers, they find features like edge detection and colors, which is standard image processing. And these features are extracting information that are interesting in all image-based networks. So the knowledge is very transferable. The later layers learn more specific tasks or features. We replace some layers, not all, typically in the end to repurpose the task, but sometimes also in the beginning. If we change image input size, for example, then we change the first layer, and the output size, we change the last layer as well. Then we train the network again with a new task and a new data set, because now we are training it for our own data set from the pre-trained network. And we can use the new network on the test images and see how it behaves, how much accuracy we get. And then further we go for the deployment of the network. So the important part is to select the model itself wisely, and then pre-train using and transfer learn the model according to your need. Are we still here? Yes. Good. Okay, so we have taken a pre-trained network SqueezeNet in this example. I have shown you the SqueezeNet in the table. And that is trained for more than 1 million images and can categorize 1,000 classes of size 227 by 227 pixels. But the problem what I have is I want to classify around 60,000 images with 10 classes of size 32 by 32. So you see, there is a pre-trained network, and now I need to transfer learn that network according to my need, and then further on. So we start with looking at our hardware target. In this case, we took a simple Raspberry Pi. We choose a very small model to do transfer learning, which is SqueezeNet in this case. And then we remove some filters inside the model, inside the network, which is called pruning. And we assume that the network is over-parameterized because there was a lot of training already done for 10,000 categories, over 1 million images. And then we come to the quantization part, and we quantize the parameters to int 8, and then we go to deploy the network and see the results onto the hardware. So when we do transfer learning, we have to change a couple of layers. As I mentioned, this can be done programmatically in MATLAB or on command line. But it can be done interactively with the tools within MathWorks, deep network design kind of tools. I'm using here Deep Network Designer, where you see a lot of different networks. You see image networks, and if I can scroll, it is a picture, but there are a lot of different networks. And then there are different phases, like if you're getting started, creating a new network, or transfer learning the model. Okay, so we can scroll here to find our pre-trained model, QuizNet. We can open that up and see the design of the network. We will have to replace the input layer since the original network was 227 by 227, but our need is 32 by 32 pixels. So we just change the input layer. Further, we will change some more layers like convolutional layer here. The size will be the same as filters, but we want to increase the learning rate because now it's transfer learning, so we just need to learn it fast. It's already learned. And you see we are changing some parameters here, and then we will also change some of the very last layers, like the last convolution layer, so that it fits the new task better, which is to classify 10 classes. So earlier it was 1,000 classes, now we have to change it to 10 different classes to classify. And then we can change the output layer after that for the same reason as above, because we need an output image in this case. So you see the classification. We remove that classification layer from here, and then we will add another classification output layer with our requirement. Then we analyze here the network itself. And once the analysis is done by this Deep Network Designer, let's see. So I need to go back in this video. Anyway, I think it's not possible here. But anyway, probably you have seen that there were, when we trained this network, there were 727 prunable filters or parameters, 727,000 prunable filters into the transfer, after the transfer learning of the model. So after that, we come to the transfer learning part. We have taken the network already from the QuizNet, and now we will transfer learn that part. We just created the network with the smallest data set, and to train it, we will just need to call this function train network. You see train network on the very top, and this function will actually train the input network, which is LGraph with some options, and give you the transfer learn network. Let's see it in progress. So once we start training of the new network, I will just speed it up. This video it takes some time. So after the speeding of the process, you see this accuracy is improving, and we received some final percentage of the accuracy. And when the training has reached an end, we take a look at the accuracy and compare it with the actual as well, and we see that the accuracy is 79.5, which is almost 80%. If we are good with this accuracy, we can go further. If we are not, then this is an iterative process. We need to select another network and come back again for the transfer learning process and see, okay, are we happy with the network, what we have taken? So the first compression step is to do the network pruning. And this is when we remove the entire filters, which are a group of neurons inside the network. This particular kind of pruning is called Taylor pruning, which we support in MATLAB. We will have to go through a flow here where we iteratively evaluate certain score, and which is handled by update score function, and then compare it with thresholds. And once this is done with update score, then we will find the score and compare it, update our prunable filters further on. So we will now start the pruning, and you will be able to see that the number of filters which are left in the networks keep on decreasing. So you see the process is started, And there will be green curve here, or the graph, and we started from something like 2,500 prunable filters, and this prunable technique, Taylor pruning, decreases until 1,500. And if I increase this loop, because I have just taken this example for 30 iterations, you can increase that iterations to further on, and you will, of course, come up with much less filters, but of course, the accuracy will be disturbed as well. So if you are happy with that accuracy, of course, you can take. So once we have taken that, we will train that network again, and you see it's started right from the 80% because the network is already trained now. We have just reduced the network size from the pruning process. So once this is done, we have now trained the network. We can go further. And it's interesting to analyze the prune network a bit further and see where the network we ended up removing the most filters. We have ended up with removing some filters, but where we need to see. So just for comparison here, I am comparing the original network and the prune network, and you see a lot of different layers on the x-axis, and the orange bars, they are the reduced size of the network. And if I just calculate the pruned accuracy, you see it's now 81%, then from earlier 80%. So accuracy is not that much changed, even it is increased. And here you see the original network was taking 2.7 megabytes of memory, and I told you that there were 727 network learnables, 727 kilo learnables in the original network, and now it's reduced almost to half, or 42% change. So if this is acceptable, then go ahead. If this is your memory criteria. Otherwise, we need to, there is another next step, quantization as well. So you can go to quantization and see how much you can gain from that, if that is acceptable. Otherwise, iterative process. So the last part in this compression step or memory reducing step is to do the quantization. I speak earlier about the fixed point implementation or designer toolbox, and we have an app for that. Let me just click on that. You see from here we select apps and deep network quantizer. There are a lot of different apps. This specific app will do the stuff for us. We'll open up that app, and then we will input our pruned network here. And the next step is to calibrate that network to represent our data, like in this case, the training data. And it will find the dynamic ranges of every filter. It will take some time, of course, and will show us the graph. So once it is done, now you will see that gray graphs are taking. So the major part is in the blue part, so we can get rid of the gray part. That accuracy is gone. So once it is done, then we can further go and run a validation test onto this quantized network. And by the way, here I have not shown, but here you can select the hardware settings, and according to the hardware net settings, and it will quantize according to that. So once it has quantized and validated the stuff, you see the floating point network, the prune network, 1.6 megabyte was taking. Prune network, not the original one. But after the quantization, it's taking like 0.42 megabytes, I guess, yeah. And it's a almost 75% change into the memory size further from the prune network itself, not from the original. And if this memory size is good enough, I think we can go ahead and deploy that. But so far, we are talking everything in MATLAB. So just a recap, what you have seen so far. You have selected a network from the deep network designer according to your need. And then you pruned that network to reduce the filter size. And further, we have used quantizer, or you can do manual quantization as well, fixed point. If you can do that, you can do the fixed point implementation by yourself and quantize the network manually. And once that is done, the further process is to deploy. But so far, we are talking about MATLAB. Now, for deployment, we cannot deploy MATLAB onto the Raspberry Pi or embedded hardware. So here it comes, the bigger part, C, C++ into the action, or PLC, for example, or CUDA on GPUs. So MATLAB has the tendency, MATLAB has the tools, MathWorks has the tools for converting the code. So MATLAB Coder is one of the very good tool which help us to generate C and C++ code from our MATLAB algorithms. And with this approach, we will see much less time writing and debugging low-level C, C++ code. So you are working within one environment, maybe MATLAB, or along with Python or something like that, whatever. Just for the input here, you can train network in MATLAB, or you can import network from Python as well, so PyTorch or TensorFlow or Onyx. So you can import those networks as well, and you can do the further process and deploy that networks. And anyway, so MATLAB Coder will help you to translate your MATLAB design algorithm or Simulink design algorithm to C, C++. And you have multiple options. You can generate C, C++ code, or executable, just for quick prototyping, libraries, or MEX. MEX is MATLAB executable, just to verify the process within MATLAB. What's the advantage? You have only one design within MATLAB. You don't need to take repositories, and if you have changed, if you do develop MATLAB code and you translate it manually, you need to take care of both repositories separately. If bug is fixed in one, bug shall be fixed in another one to check it. But in this case, you have to fix the bug in, or the problem in MATLAB, add the feature in MATLAB, and translate it to C++ quickly, test more systematically, and of course, focus on development, algorithm development more. So here, with the code generation, we support a lot of different tools. For example, GPU, FPGAs, we can deploy Verilog code or Vlog code as well. For microcontroller or PLCs or CPU, C, C++ code. And a lot of vendors we support, the different hardware we support. So from GPU, we support NVIDIA, but from CPU, we support a lot of different hardwares and vendors. And on top of this MATLAB Coder, there are free applications available from MathWorks, which we call hardware support packages. So they are like supporting specific hardwares. For example, Raspberry Pi, in this example, I have used hardware support package from Raspberry Pi, which is built by MathWorks. And that is freely available if you have MATLAB Coder, embedded coder, and you can work with that and deploy the code easily. All right, so our target today was a Raspberry Pi. So let's see how we can generate code from the network. So here you can see that this structure, coder.config, is created for, so can we raise hand if we know processor in the loop? Okay, good. So processor in the loop is you have a processor and you are testing. So when you test your software or the coding, you create your test cases, test benches, and test it within, for example, Linux environment or Windows environment. But when you want to deploy it onto the target and test it with environment, so processor is in the loop of the testing phase, of the verification phase. So you are actually taking the code, deploying onto the target, and getting the results from the target back and comparing onto the PC. That's what processor in the loop is. And we support that in this MATLAB Coder toolbox. So you have this processor in the loop verification mode. We selected the target language as C++. Deep learning configuration for ARM compute, okay, further on. And this was the mat file for after the quantization. Once we did the quantization, we add that quantization parameters here. Data type as int8. And then we run this command, codegen. And once we run the command, this was the main function, squeeze-net predict, which we are actually, we are trying to generate code for this specific function. And you can see it here, squeeze-net predict, with some arguments, general arguments, and configuration. So now it's in code generation is successful here. You can see that connectivity with the Raspberry Pi is done. And then here, I will try to run both the networks, the actual network on PC, and this one, _pill, will run onto the hardware. So once I run this pill, this is the executable from the code gen, then it will deploy that onto the target, and we see the results here, that both the PC version of Pro Network and ARM compute version onto the hardware gives the same results. Great. And then it comes to the memory comparison, which was the main task to reduce the memory. So you see, now I have run both networks onto the hardware as well. So this is the actual network without pruning, just the transfer net network like SqueezeNet with 32 by 32. So this is the memory. It takes 22,652. I think it's in kilobytes, or I don't know, but I think it's in kilobytes. And taking 1.2% of the memory. I'm using here as an example Raspberry Pi 4. And after the SqueezeNet quantized model and deployed onto the hardware, it takes 4260, which is 0.2% of the memory. And if you compare the memory size, it is reduced 81%. Great. So let's have a recap for this. We selected our test software, MATLAB or Simulink, or on PC some other toolbox, whatever. We trained our network using, in this case, we used Deep Network Designer. And then we tried tailor pruning. Using tailor prunable network function, we reduced the size of the neural network itself by eliminating some of the prunable filters. Further, we quantized using Deep Network Quantizer and come up with int8 of variables instead of single precision float. And then comes to the deployment onto C++, Raspberry Pi using C++. We used MATLAB Coder. And by the way, I've shown you the command line of the code gen and MATLAB Coder. There is an app as well for that. You can enter your function and generate code for that. And there are different phases for that. You see inputs and define and generate results. But this is probably another topic. So yeah, I think that's all for now. So in the end, you can fit AI for many applications, and MathWorks tools here can work easily and help you to decrease that size and constraints for the hardware and deploy it onto the hardware. Thank you.
Thank you, Waqas.
Thank you.
Now it's time for questions, so please raise your hand if you have any questions, and our volunteer will come to you. I can't see anything, so yeah.
Hi. I have a question about this MathWorks tools. So this is the, all the functions are built in the MathWorks, so you have to just, when you are writing your script in the MATLAB, you are using the predefined functions, or you wrote the pruning functions by your own?
Thank you. Very good question. When I talk about the toolboxes itself, for example, the Deep Network Designer, the Tailor Prune Network, these functions are built in. So once you buy the product itself, then you have those functions built in. Like in MATLAB, you have function for factorial. You don't need to build that factorial, code that factorial function. But so, and on top of that, you have, for example, if I take this example, code gen. So you are generating code from your MATLAB algorithm. But if you really need to include something from external third-party software, like drivers, or if you have written very optimized code by yourself, manual code, you can add that code along with the MATLAB algorithms and MATLAB coder will help you to generate all those together in one project and generate that. So you have the flexibility. Further, you have a flexibility to call other software, for example, C++ from MATLAB and from C++ to MATLAB. You have the tendency to that as well. But whatever I have shown here are built in to MATLAB.
Hi. So actually, you mentioned when you talk about this code generator that it's possible to using TensorFlow. So is it anyhow possible? Do you have any tools which can convert the model from TensorFlow to MATLAB and then generate C++ code from that? Or you just calling this like from Python?
No, I think that is calling from Python.
Mm-hmm.
You can import those models, and then you can further export those models back. So now we have export functionality as well. But I think what I know is that there is, when you use MATLAB coder to deploy, there will be a glue with your network from TensorFlow, which is TensorFlow Lite for the hardware implementation. So I will talk about TensorFlow Lite. So TensorFlow Lite and the MATLAB algorithm part, it will be glued together and will be deployed onto the target.
Thanks.
Welcome.
Do we have any more questions? Okay, I guess not. So Waqas, thank you once again. We have a
Thank you
small
very
gift to you, for you.
Thank you very much.
Okay, thank you once again.
Thank you.
Okay, and for all of you, right now we have 15 minutes of break until 10:15. So you can go switch the rooms, you can go play arcade games, talk with our speakers, or just get accustomed with the cinema. So I hope to see you soon in 15 minutes. So thank you very much for your patience, and see you later. 1, 2, 1, 2. Right now it's okay? Yes, okay. Welcome everybody, once again, I hope so, in the room number 7, on the 9th CodeDive conference. Once again, we are in a hybrid mode, so all of the lectures will be available on the stream after the conference. I just want to ask you to mute your phones because we don't want to interrupt our speaker. And our next guest is Sadegh Karimi. And Sadegh is experienced in telecommunication industry, and currently he's working in Nokia R&D center in Poland. He has skills in Linux, Python, and Docker, and he's willing to use AI and machine learning in the telco industry. He likes exploring the world by listening to podcasts. Sadegh, come on the stage. Good luck.
Thank you. Hello, everyone. I am Sadegh, and I'm really glad to be here presenting my speech. And this is about... there is a QR code here. You can scan it, and it will redirect you to the GitHub page dedicated for this talk. You can find the codes, the slides in a more complete slides. There is a more complete slide there and some codes. So actually, I'm accused of having the longest title ever in any conference. So it is about how to model a stochastic behavior of failures in telco or IT system using machine learning. And this talk is about hardware estimation and maintenance. So here on the screen, we have two of great product of Nokia. On the left, we can see a airframe OpenEdge server, which is a general purpose server and is dedicated for running general applications. And on the right side, we have AirScale baseband, which is a customized hardware and dedicated only for special use case in telecommunication. The reason that I'm showing this picture is that I want to emphasize that this talk is about any hardware. Doesn't matter it is a general purpose or it's a customized or a specific use purpose. So one of the important factors that we need to have in our network, any network, IT or telecommunication, is to maintain our hardwares, which means that we need to take care of them to provide a good quality of service to the end user. So we need to always take care and keep them in the best possible conditions. To do that, we have two kind of options, and there are two maintenance options. One of them is corrective maintenance, which means that first we will have a failure and then we attend to fix that failure. The other one is preventive maintenance and means that before any failure happens, we try to fix the problem. So we will prevent any issue. So these two are known as to be CM for corrective maintenance and PM. I will be referring to CM and PM a lot during this talk. So what are the disadvantages of having a CM approach in a network? The first one is we will face income. We will have income loss, but in PM, we will have no income loss. We will prevent income loss. Also, in CM, we will have reputation damage because already a failure happened, and it takes time for us to fix that problem. But in PM, again, we prevent that kind of reputation damage to our brand. In CM, one of the advantages is that we don't need to perform many resource planning. It requires less resource planning. We just wait, failure happens, we attend and fix the problem. But in CM, we need more resource planning. We always need to take care of assigning team to the tasks. Also, in CM, we expect to have expensive repairs because hardware is maybe damaged, we need to replace it, but in PM, we prevent that expensive damage. Also, in CM, we have longer downtime because we need to take time to find the issue, but in PM, we can manage the downtime, for example, postpone it during the night and fix the problem. Okay, a conventional method that is being used by many, at least mobile operators or other IT system, is that they have a CM. In their network, CM is playing an active role. Means that they first face the failure and then they will perform the fix. Also, they perform preventive maintenance, but it's on a regular basis. And here you can see our network, and that's not an oil barrel. Actually, that's supposed to be a database, so don't get me wrong. And we have a network. We collect the data and alarms, and this is generally alarms because CM is mostly performing based on alarms. And then we have our analysis, which is not a deep analysis. We just sort the alarms according to their importance. And then we will perform CM. This method is anticipate the failure and try to fix it before they happen. So PM in this method is playing an active role. Here is again our network. We collected data and alarms. We also can use other kind of data like KPIs. We will perform a deeper analysis. Then we estimate which node is going to face the failure using, for example, neural network. And then we provide a model to sort the tasks and find the most probable failures. And at the end, we perform the preventive maintenance. Okay, for the rest of the talk, here is the roadmap. You can see a road, not a straight one, but we have 4 checkpoints. The first one is data collection and system design. I briefly introduce how to collect the data. Then we will have a statistical analysis. After that, we have estimation of the failure using machine learning. And at the end, we have the final modeling. Okay, about data collection and system design, we have many options, but one of the famous and cloud-native based solution is Prometheus, which is a graduated project of CNCF community. So suppose that we have a monitoring server and we want to collect the data. So we will install Prometheus over that monitoring server. Then we have our targets nodes. Doesn't matter if it is a customized or general purpose, but for telco, it is not ready yet for the cloud native, fully cloud native. So suppose it is a general server, and we can have other targets as well, like containers, like mixture of containers and servers. And for sure, we have the connectivity between these servers, and we have our scrapers. Scraper is again, Prometheus product, which is supposed to scrape the alarms and logs and send them back to the monitoring server. So on the screen, you can see the node exporter, which is designed for OS metrics scraping, which means it is sending the general alarms like CPU percentage or like hardware, disk read and write, and memory usage. And we can have our scraper, we call it any scraper, and we can have our scraper designed for our network in the way that we want to work. And we have MTail, which is an open source solution designed by Google, and it is intended to act like a tail-f in Linux, and it watch the entries to a log file, and after any changes, it will calculate the counters and it will send them to the main server. Also, we could have our telco structure. We have NMS server. It is specifically designed to collect the data and alarms. What is Prometheus? I will not deeply introduce Prometheus here, but I will just briefly introduce it. Prometheus, and this picture is taken from Prometheus website. I should have sourced it, but I forget. Here is the Prometheus structure. It has different components. The main component is Prometheus server, which is designed to retrieve the data. It has 3 services: retrieval, TSDB, and HTTP server. It retrieves the data from targets, then it stores them in the TSDB service, a time series database, and it has another service which is HTTP server and is dedicated to communicate with other entities. We have our exporters, which they are scraping the target and sending the data to the monitoring server, and we have our push gateway, which is designed to collect the data from short-lived jobs. And if you wonder that what is the short-lived job, it is a piece of code. Suppose it is a piece of code which is running once in a while. We don't know when, but when it is running, we want to collect its data. So we provide few codes in the middle of our, for example, C++ code or Python code. And when it is running, it will push the data to the push gateway, and push gateway will send the data to the Prometheus server. We have service discovery for the networks, which, for example, are supporting Kubernetes. We don't know which node is currently running because they are increasing and decreasing due to the service load, according to the service load. So we will configure a DNS domain, and it will try to find the target nodes automatically. We have visualization dashboard. They are using PromQL language, which query the required data from monitoring from Prometheus server. And finally, we have alert manager component, which is designed to signal alerts. Like, for example, if CPU is being over 90% for 1 hour, it can generate, you can configure it, and it will generate alarms. So it is the final configuration. We will install OS metrics scraper, which is node exporter, and log file. We will be using log file for this talk. Suppose that we have a log file called any log file.log, and we have kind of data which are not in a standard format. The first column is time series database, the second is IP, and the rest are hardware faults and overheating alarms. So we want to scrape this log in a format that is possible to be stored in TSDB Prometheus server. So we use mtail. Okay, let's go to the second section. I will be briefly perform a statistical analysis because it's needed as a base foundation for the rest of the talk. Here on the right side, we can have our list of features, which are our alarms. They are hardware alarms, CPU errors. Suppose that we configure the mtail to scrape these logs, and they are ready to be used. And we have different features. We call them input or features. We use pandas data frame to read the data. It's in CSV, and then we describe it using an API method called describe, which is in pandas data frame. And we will have our data like minimum, maximum, and the ranges. Here on this log file, we are facing a very sparse log file, which means that we have a lot of 0 elements. This is very tricky, and it is hard to analyze such logs. So we have to deal with it. And we have another feature or entry called TLPM, which is time to last preventive maintenance, and we will be using this feature input for the further analysis. And it is number of days. So its range is from 0 to 365. And it means that if it is, for example, 20, means that 20 days ago we have performed a preventive maintenance for a single node. Also, we have TLCM, which is time to last corrective maintenance, and means that, for example, if its value is 50, means that we have performed a CM activity on a node last 50 days. We have also number of PMs, which means how many times we perform a preventive maintenance on a node in our network. It ranges from 1 to 4, and this data is a real data collected from a mobile network operator. We have also priority, which we prioritize our nodes. Under this data set, it is from 1 to 4. But we can have a wider range. And we have another category, other alarms. And finally, failure, which shows us how many times that node has faced failure during the past year. Here is the histogram, which shows us time to last corrective maintenance histogram according to each number of PM. For example, if we perform 1 PM in a year for a node, we have that blue histogram, which tends to be on the left side of the horizontal axis. And it means that if we perform 1 time preventive maintenance, we will have less time to last corrective maintenance, or we could say we will have less time to failure. We expect our node to be failed sooner than later. So also we will have other histogram for PM number of 4 in the red one, which is intended to be on the right side of the histogram. And it shows that the higher number of PM is, the time to failure is higher. So we will be in a better situation if we perform more number of PMs. Another way to show it is this box plot, and it shows that the higher the number of PM, the higher the range of the TLCM is. And again, we separate this histogram. We want to fit a probability density function over this data. The dashed line is probability, which is fitted over this data. For the first and second one is gamma distribution, but with different parameters. For the third one is variable, and for the last one is norm. And how to analyze this kind of histogram. If you ask me, that give me a strict number that how many days I expect to face a failure for a node, and if you perform, for example, once in a year PM, I could say on average you could expect around 100 days, but it could be for sure less and also more. So on average, we have a knowledge that how many days we should expect that failure. This is not accurate one, but having at least a bit of knowledge is better than having no knowledge. We also can have it for other number of PMs. For example, for the number of PM4, we will have the value of 200. Our average expected dates are 200 days. How to plot such beautiful histogram? It is we are using a pandas data frame again, and we also load from SciPy stats. We import gamma, variable, and norm distribution to plot our dashed line. We will import matplotlib for the presentation for the plotting purpose, and we import the fitter function to fit those histograms over our data. And we again read the data, we activate figure 1, and we use PLT method from hist method from PLT library to plot this histogram, and number of mean is 100, and also we sort the data according to the number of PMs. We filter them. For example, here is number 1, and we fetch the column TLCM. For the rest is the same, so I will skip this. And we add labels and titles, and we activate the grid, and finally the legend. And to plot, to find out which PDFs are fitting the most over our data, we activate figure 2. Again, we activate subplot 1 for the blue one, and we fetch our data and store it in a variable called data in. We call the fitter method, and we pass the data and list of our distribution. And the list of distribution is decided according to the shape of the histogram. They seems to be more likely like gamma, variable, and norm. and then we feed the data and we print the results, and finally we fetch our parameters like alpha, location, scale, and we plot the dashed line using horizontal axis using line space, and the vertical axis using the, for example, for blue band, gamma PDF. And we will have the dashed line at the end. So again, we will activate some grid on, legends, and for the remaining is the same. Okay, let's go to the next section, which is estimation of failure. And let's remind you what is the goal of the estimation. Our goal is to anticipate the most probable failures. Which node is going to face failures sooner than others. We have two methods. Method one is to fit a probability function over our data. It is what we did in the last section. And we somehow anticipated how many days we will face the failure. But it was not accurate because it was a one-dimensional PDF. We could have more dimensional, like two-dimensional, three-dimensional. But it is not that much accurate for sure. We will be using method 2, which is using the neural network for estimation. And what is the neural network? A brief introduction. It is a mathematical method to somehow simulate how the brain works. It has many components and layers. For example, input layer to receive the inputs or features. The second layer is hidden layer, or it can be 1, 2 or more, or it can be none. Because if the underlying pattern in the data is more complex, we will have higher number of hidden layers. And the final layer is output layer. We have components like neurons and connections, which connects neurons together, and it has a weight. And that weight is being learned during the learning process. And finally, we have activation, which runs over our state of the neurons, and it can try to, for example, model nonlinearity in our data. We can have different options for activations. And how to create a neural network to estimate the number of failures. Again, we will use pandas. It is always there. Doesn't matter what kind of model we are creating. We import matplotlib for the purpose of the plotting. We import from TensorFlow models, layers, and metrics, which we will be using them in the model. We also import SHAP library, which I really like this library, and you will soon like it too. And I will recommend you to use it in few slides. And we will load the whole TensorFlow. This is not a good way to do, but for the ease of coding, I did. It requires a lot of memory for sure if you load the whole library. And we set the random seed to be 5, which means that every time we run the code, it initiates our neurons at first with same value, because the value of the weights is set to be random at the first that we run the model. And we again read the data, and we create our first step, a sequential model, which is an empty space on the right side of the screen. Then we have our first layers, which are hidden and input together. And number of inputs is equal to the number of our features, like those hardware alarms, overheating alarm, TLC and TLPM. And hidden layer 1 is with 8 units, means 8 neurons. And if you wonder how to estimate and how to calculate these neurons, there is not a general rule, but you can, for example, create your own methodology. For example, the way I do is that I will, if it is a complex data, I will divide by 2, and the number of neurons will be, for example, here around 8 for the first hidden layer, and then a quarter of input feature will be for the second hidden layer. We have another layer called dropout, we will use this layer to control overfitting, because one of the major problems that we have in neural network is that most of the time we fit the model very good on the training data set, but later on it will fail to estimate because it is fully fitted over the data. So we will purge some neuron states at this layer to control the overfitting effect. And the percentage is 50%. Then we have our connections, which are learned during the learning process. We cannot define them here, but as we are using dense, this means that we have a fully connected neurons between two layers. And this value of the weights will be learned during the learning process. Then we have our hidden layer 2 with 4 neurons, our dropout 2 for hidden 2, and it is intended again for the overfitting. And finally, we have our output layer with 1 unit. Our problem here is called regression. That means we are going to find an integer value, but we can design our network for classification and other kind of usages. And then we compile our method using an optimizer called ADA delta. You can use other optimizers. It's the matter of try and error. You have to try and test them. And we also have our loss to be mean square error, which means that we will measure the difference between the real value of the target and what we estimate. And as this difference is lower, we will have a perfect learning process. And we, again, separate the failures, our target in variable data out, our input features in data in, and we drop the target from the input feature. We load 1,000 of the data samples, and we change them to be NumPy using dot values. And for the target, we will do the same. And finally, we fit the model over our data using X training and Y training for inputs and targets. And we have batch size 8, epochs 3,000, and shuffle to be true. And if you wonder what are those values, these values means that we will give the whole data set, 1,000 data set, 3,000 times to the model every time we shuffle the data. And after model visits 8 samples, we update the weights. This is the meaning of those parameters. And here is the result of training process and also validation process. As you can see, as we have the higher number of epochs, we have the lower error. And because we used dropout, at the tail of the graph, we won't have any lower value, but it will start fluctuating around that mean value. And I will skip how to create this graph. You can find it on the GitHub page. And here is the figure that I want to talk about more. It is the result of SHAP library. And as you know, when we design a neural network, mostly it is a black box for us. We don't know what is happening there really, what is happening inside. To change that black box to a gray box, we can use this library, and this library will tell us for each feature how much the value of the target, estimated target, will be changed. On the top, you can see the value of TLPM, which its effect is 1.3, and our target value is 2 here, and the estimated value here is 2.3, and our estimation is good enough, I believe, and it shows that TLPM has the most effect for this estimation. And also, the red means it is increased the value, the blue means it decreased the value, and those little fluctuation you can see for red and blues, this is because we have a sparse data set, which means, again, a lot of zero data in our data set. How to create such a beautiful waterfall? Here, we first select one single input to perform analysis on that sample, and we load it into data in explainer and its output to data out explainer. Then we call explainer API from SHAP library, and we give the model and the initial training set to this explainer to learn the model, the training procedure. And we export the values to SHAP values using explainer, using the sample input. Then we extract those values because they are like nested in the list. We have a base value, which is the starting point. We have the values, which are the value of the red and blues. And we also extract the data of our features and at last the column name. We activate figure 2. And we call explanation API from SHAP library, and we pass those values, base values, and data and column names. Then we call the waterfall and give the explanation object result to that waterfall, and it will show the plot. And SHAP waterfall is working over Matplotlib. So we can use Matplotlib to modify fonts, add title, and activate the grid, and also at the end show the plots. Okay, so far we have anticipated the value, the estimation of the failures for our nodes. Now we want to present how to perform PM. So for the modeling purpose, suppose that as an operator, we have a lot of hardwares and we have a lot of, for example, here in the telco industry, we have a lot of radio nodes, BTSs around the country. One of them is in the Dolnośląskiego state. And we have a few of teams which they are supposed to perform those tasks for us. What is obvious is that the number of nodes is much higher than the number of teams. Suppose that the number of nodes, for example, to be 10,000, and the team to be, for example, here is 3, but, for example, 20, 30. So they have to perform PM for all the nodes. But it's not possible. They have to sort them out, which node to take care of first. And each node creates a value for us. Some of them, they create income for us. Some of them are mostly related to reputation. For example, suppose we have a call center here, and we have our customers. And if we face outage here, then what will customer says? Okay, they have a failure in their customer center. What about other places? So we need to always take care of that BTS. So that one is a high priority for us. So these BTSs have alarms and some data. In telecommunication, if you find a node which has no alarm, that node for sure has a problem. So most of the nodes have few alarms. So we need to take care of those alarms to prevent the failures. So what we will do, before I continue with this slide, forgive me because I don't want to change the code dive to math dive, but I have to give you some mathematical terms. So we have probable financial loss, which we calculate for each node, and we find the probability of failure for each node, and we find how much income it has for us in a day. And we multiply those two together. So the final result is CI, which is probable financial loss. For each node, we calculate that one. And we have probable non-financial loss. Again, we find the probability of failure for each node. We rate the node between 0 and 100 based on the importance. We know that which one is important, more important for us. And we have PI at the end, which is multiplication of those parameters. So remember Ci and Pi. We will see them soon. So here is the sets and indices. We have to define few mathematical terms, and I is set of all available tasks. Suppose that we have 1,000 tasks, and it is in programming terms, it is a list of some strings, or suppose it is in C++, it is an array of strings. M is a set of all available workforces, all our teams. Suppose again, this is a list of strings again. So I try to, at the same time, translate them to the programming to make them easier to be understand. And we have Ci and Pi, which I already told you. We have Tm, which is availability of the hours for each team. And we have AIM, which is the time consumed by workforce M to perform task M. Because we consider that each team has different skills. For example, team 1 maybe is more skilled than team 2, so it will take less time to fix the problem. We have our variables that we want to find out what are the values. YIM is equal to 1 if workforce M is assigned to team I. So if team 1 is assigned to BTS number 1, Y11 will be 1 for that mapping. And we have WI, which means it is 1 if the task I is selected to be performed. So at the end, we want to find which BTSs should be selected and which team for which BTS. We have cost function. Cost functions are summation of financial loss, and the other one is summation of non-financial loss. And we sum them with a weighted sum because we want to, for example, for us, reputation is more important than the income, which I believe it's not true. Income is more important in many cases. So we will choose alpha 1 higher than alpha 2. For example, 30% against 30%. And we have our limitation. WI should be binary value. YIM should be binary because it is we select it or we don't select it. We have summation of YIM equal to WI, which means that for each task, we only assign a single team, not more than that. And we have to respect the team available time because they don't want to work after 5, so they have a limitation. So we consider that term in the constraint number 4, and we ask how many times that they have performed the task. It should be less than their available time. So let's find the code, how it works. We use Pyomo library, which is intended to solve this kind of mathematical problems. We import OPT and environment from this library, and we call as PO and PE. It is a list of our tasks, and our tasks are BTS 1, 3, for example, to 10. And it is a list of our available team. And here is the CI value, which is probable financial loss for each node. It is an example. Here is the PI. We rate the nodes from 0 to 100, and these are the value of the multiplication. This is the available time for each team, 2 to 3, and we wonder that those teams are really working. They seems to be very lazy. So, and we have AIM, which is intended to specify for us, for each node, which team, how much time could fix the problem. And we continue with creating an empty solver using GLPK. And we create a concrete model here, and we start defining sets and indices. First, we define I using pe.set, and we initialize it with the I. We also add m, and we initialize it with m. We have our parameter declaration. We can define ci, and we initialize it with ci, which we defined above. And same for pi, same for m, actually, and tm, and finally for aim. We initialize these parameters using the above values to try to run the code. So we declare variables. Yim, it's supposed to be binary, so we define it here, that constraint. And wi, which we use pe.var to define those variables, and we are willing to find out what are the value of these two. We define our cost function because it requires some mathematical summation. We define a function, and we pass this function to the objective, pe.objective. And we consider to maximize the damage and income loss. If we maximize it, then we find out which node is maximize this damage and income loss, and we will try to fix that node. And we also define our constraint. The constraint on the right left, on the right down, you can see those constraints. The first one and two are already defined up there in the code. And the third one, we will define the third one and the fourth. We are defining them here using, again, another function because they are somehow a bit complicated. So PyOmo allows us to use such kind of function definition, and we define those constraints, and at the end we solve the model. And finally, we print the result using model.pprint. And here is the result. On the top, we can see the value of wi, which means that out of our all tasks, which tasks are selected to be performed. For example, BTS1 is selected, BTS3 is selected, but BTS4 is not selected. That means that BTS1 and 3 are make us higher income or have higher reputation, makes higher reputation for us. Below we can have, next slide is spoiled. We can have VIM, which shows us which team should attend which tasks. On the right, for a better presentation, for example, team 3 will attend 2 tasks, team 1 will attend 1 task, and team 2 again 1 task. And thank you very much for being patient. And here is another QR code, which is my LinkedIn, and I will be happy to be connected in the LinkedIn. Thank you again. Thank you.
Thank you. So now it's time for Q&A. If anybody has a question, please raise your hand, and our volunteer will come to you with the microphone.
First of all, thank you for your talk.
Thank you.
I do have a question. How would you scale this? Because what you're doing is basically integer linear programming.
Okay, yes.
And it works well for small problems, but if you scale it to thousands of BTSs, then it would take too long to solve.
Are you talking about the estimation? I mean, neural
I'm
network
saying
model?
about the last part, so the basically assigned teams.
Okay. Yes. Actually, we are sorting out the tasks, but for example, we have a team of, for example, team of 20 and 1,000 tasks. It takes a while, but it is not like this that I'm doing this all the time. You can run it on daily basis. You can collect the logs and date alarms on daily basis. For example, today I want to plan for the next days. And there is one important thing that we should think of, that CM always has the highest priority, because our active role here is PM, but sometimes CM is also happening. So we have to also consider that factor. So it is not like that we always want to run this. It is, for example, I run it today for the whole network, and I will start fix the problems. And if any changes, for example, happen which is critical, I can rerun the model and again assigns the tasks.
Okay, thank you.
You're welcome.
Standard ML question. So in this regression model that you have presented, why all the activation functions are linear? There was no, like, wasn't it better to use like non-linearity there?
Very good question. Thank you for that one. Actually, the reason that we use linear, because if we plot the correlation between the number of failures and, for example, input features, we can find out the correlation is a line, and it is spread around a line. So it is not that relation between input feature and the target is not nonlinear. So that's why we used linear activation function to model that one. And if we try, for example, another kind of activation function, I think that won't work because this is completely a linear relation between input and outputs.
Do we have more questions? I guess not. Okay, so Sadegh, once
Thank you
again,
very much.
Thank you very
Thank you.
much. No. We have a small gift for you. So
Okay.
okay, please stay on stage for a while.
Thank you very much. Thank you.
Okay,
Thank you
once again.
Thank you for having
You
me.
can sit down.
Thank you.
Okay, and before we will go to coffee break, I have some organizational things to tell you. Please remember about the room number 8, where there is a tournament with arcade games. There are amazing prize to win. There's also an envelope contest where you can find an envelope and answer the question. And grab your coffee here or in the bistro on the ground floor. So right now we have 30 minutes of break, and I hope to see you soon later. Thank you very much. Everybody, once again, in the room number 7 on the 9th Code Dive conference, organized in the hybrid mode in Kino Nowe Horyzonty by Nokia. As I said, we are in the hybrid mode, so right now we will have an online lecture. Today, Vinay, Kumar and Chandana will tell us a little bit more about auto keywords generation in robot framework using machine learning algorithm. A little words about our today speakers. Vinay, outside of work, he's a singer and composer of poems in Kannada language, and he has received several awards in the area of social service, animal welfare category. Involved in various cultural activities, which were held at the office's premises as well. Chandana. She started as a full-stack developer in Python in Nokia 2014. Currently, working as a technical leader in mobile networks domain. As an automation enthusiast, she developed libraries to support various technologies in robot framework. She's focused on efficiency and effectiveness. She designed and implemented new automation methodologies. Experienced in developing of many tools involved in technologies like AI, ML, UI development, and web development to support business processes. Although they can't see us right now, please welcome them on the lecture.
Yeah, thank you. Hello, everyone. So today we are going to discuss about the topic auto keywords generation in robot framework using machine learning algorithm. So as part of this topic, we will be having introduction on AAML and some kind of steps involved and types of machine learning and which algorithm suits to this particular purpose. We have introduction of that NLP, and we also have introduction of robot framework. And why do we need to have this particular tool? So basically, we have a lot of software products available where we need a lot of features involved into it, lot of software enhancements, corrections, modification, and deletion. So a lot of features need to be tested thoroughly. So we call it as a regression testing. So where manual testers need a lot of efforts to perform the regression testing. So we have to automate those kind of regression test cases to be stable and repeatable. So for every release, whenever a multiple features has been added, so testers have to have a knowledge on automation to write the test scripts. So the test scripts can be executed with multiple data. So each particular scenario has its own data where we write as test steps involved into it and we create as test scripts. So how do we process the test scripts? So we have a framework. So framework is set of guidelines or rules used to create and design the test scripts. So using that particular framework, we deploy and execute the test cases and actual product. So for this, we need a proficiency in automation to write a particular test scripts. So in order to have this purpose, what we are going to solve this purpose with these particular solutions. So here we are going to use artificial intelligence, machine learning, and neural networks. So let's have an introduction about these three topics. So what is an artificial intelligence? So it has a defined program that exhibits cognitive ability similar that as a human being. So it can computer can mimic our human behavior. So what is a machine learning? It enables the machine to learn itself. We don't need to program here. So it has the ability to learn by itself. So here we created data sets where the machine will learn according to the data sets and it processes accordingly. So the next, we have a technique where it is a part of ML that behaves as a neurons in a brain. So it is just like a neural networks. So that technique, we call it as a deep learning. So let's have small talk about the machine learning, why we need a machine learning. So we have a lot of data available today. So we have a machines processing such kind of data. So for example, if we take a stock market, so that is we can discover the future value of a company's stock and other financial assets traded on an exchange. So even for the call records and a pay searches, so a lot of data can be processed. It also helps in technologically aiding decision making, like for example, cancer detection, credit analysis, etc. So also it has an ability in the neural networks where it does the image processing, where you can remove the noises of the image. So let's have an overview of machine learning in detail. So this is, we have an artificial intelligence layered mechanism. So first, artificial intelligence, so then machine learning and a deep learning. So machine learning and a deep learning are part of this artificial intelligence. So machine learning requires a rule-based techniques and expert system to process the output. So the next is the planning. So for example, when a project has been assigned, we need a lot of resources to be allocated to a particular project to be successful. So in that case, we will be having like software developers, testers, architects, so many people involved into it. So there is an algorithm where you can actually plan efficiently using some kind of artificial intelligence. The next comes natural language understanding. The name itself identifies the whatever the human language we speak, that we call it as a natural language. So the artificial intelligence we are providing to a computer where it can understand our natural language, process it, and results the output. Say for example, we have a chatbots like where you can send a queries and you can get the response accordingly. So and one more is a robotics, where you provide artificial intelligence to the robot to think like a human when you send a command and what the robot does it. So that's where we use an artificial intelligence over there. So when it comes to the wireless picture, so it has some channel optimizations, some kind of power energy saving. So those are some scenarios where we might use this artificial intelligence. The next coming to perceiving sounds and objects. So for example, we have a cat and a dog. So how do you identify it based on sound? Like say cat says meow and dog say bow bow. So with this kind of sound, we identify it as a cat or a dog. The same intelligence will be provided to the computer to actually identify what is a dog or what is a cat. And the next comes the problem solving and learning. So it has its own intelligence where it solves the problem by itself and also learns the problem accordingly what the solution has been provided. So next is the types of machine learning. We have three types of machine learning. One is supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is basically mostly with the labeled data. So what do you mean by labeled data? It has some kind of a tags or a names or an ID, some number. So we label it certain data. So that kind of data is part of this supervised learning. So, and we get the accurate data, accurate results as well when you go for a supervised learning. Say, for example, where we can use this supervised learning. So nowadays, we are having mobile phones with the face recognition apps. So it's a bioinformatics. So where it has a labeling of your fingerprints or a face. So all the labels will be provided. So your application or your phone get unlocks by your face recognition. So those things, examples comes under this supervised learning. And also we have a speech recognition. Like we keep using Google Assistant and Siri. So where it works only on the voice. So basis on the voice commands, it reply you back or it does the things whatever you order it. So that is one more example for this supervised learning. So next is unsupervised learning. So here in unsupervised learning, we don't have the labeling of data. So what for we can take some example here, unsupervised. For example, we do a lot of shopping in Amazon. So in Amazon, when you do shopping, it shows that okay, these are products bought together. So how do you get those things? So with this kind of learning, so it will actually shows you without any labeling. It prepares, it won't cluster pattern. Accordingly, it will advise you, okay, these are the frequently bought together, and it will advise you to for the further shopping. So that is what one example for this unsupervised learning. So the next is reinforcement learning. So this is like the learning, it takes the decision on its own. So it solves a particular kind of problem where decision making is sequential and the goal is a long term. Say for example, we have lot of mobile games available. So for each particular game, so when you play it, you get a result where it shows you the rankings. Say you are ranked 1, you are ranked 2. So on what basis? It takes its own decision, it learns itself, and it provides you the reward accordingly. So and even robotics also uses reinforcement learning. So what are the steps involved in the machine learning? The first step is always gathering the data. So we should have an appropriate data to process the data. So first we have to gather the data. Whatever the processing should happen, the data should be accurate. So once the data has been taken, we have to prepare the data. Like we have to clean up the data. There might be like a lot of unwanted data. So we have to clean up the data and remove unwanted things in the data preparation. So next step is the data wrangling. So it is like we have a raw data available here, right? So in that raw data, what it does is it structures or it transforms the data where the machine can understand it. So that's what this data wrangling does it. The next is we have to analyze the data. So we analyze the data after cleanup and having this transformation of the data. We analyze the particular data. Then what we do, we choose a model. For there are a lot of models available. So in that we choose a model which is appropriate. First we train the model. Say we have chosen the model 1. So we train the model with existing data. And what we do, we next test the model and we see the accuracy of that particular model. Okay, and we evaluate the model. So if the accuracy is low, then again we go back to this training the model. We choose a model, train it until we get the appropriate model. So once you test it and you have got the appropriate model, then the next step is we deploy it. So this is the machine learning life cycle. It happens. So in order to have a solution to our purpose, we are choosing a natural language processing algorithm. So what is this NLP? So this is like whatever we speak like normal English. So the same, whatever the human language, it keep process accordingly. So that is where it shows you this natural process, language processing. So it bridges the between the machines and people by enabling a computer to analyze what we have said. So it recognizes the speech, what we speak, and process what the user meant it. Also, to converse with the humans, a program must understand the syntax like grammar and semantics and some kind of phrases, conversion and context. So all those things can be achieved with this NLP. So next, the phases of NLP. We have 5 phases of NLP. So first one comes into the picture is the lexical analysis. The collection of words and phrases in a language is referred as a lexicon. So what it does, we have a lot of text available where it divides the text into a paragraph, a sentence, and a words. That is what we first initially do with this lexical analysis. The next comes to syntax analysis. Unlike like all the software programs, whatever we perform, we have a syntax where we need to follow. Similarly, we have a syntax for the human language, we call it as a grammar. So this analysis will happen on the grammatical of a sentences or a words, whatever we have formed it. And the next thing is semantic analysis. So this is a process of looking for a meaning in a statement. It is like mostly concentrate on the like what is the meaning of the particular statement. Say for example, I say the mango ate apple. So the syntax is correct. The grammatically it is correct. But do you think it is a logical? No, it is a illogical because mango will never eat an apple. So those things, the meaning of the sentence and all those things comes under the semantic analysis. The next is your discourse analysis. This is like, say for example, it mainly focuses on the properties of the text. Say he wanted that. It means that is what? That all depends on the previous sentences, what it has been referred to. So those kind of scenarios comes under this discourse analysis. The next comes to pragmatic analysis. This pragmatic analysis is uses the set of rules to describe the cooperative dialogues. It means the context. Basically, it basically deals with the context of the sentence. Say, for example, we say switch on the TV. It can be a request or an order. It depends on the context what we are using, whether it is a request or an order. So that comes under this pragmatic analysis. So these are the main 5 phases of the NLP. So how the data processing happens in NLP? The first thing is we have a data acquisition. So we have to have the data acquisition, complete data, we have to have it. And then we do some cleaning of the text. And the third comes the pre-processing. The pre-processing involves a lot many steps. Like, for example, we have this punctuation marks, spaces, all those things have to be removed. Even we have a stop words like a, and, the. So all those things also have to be pre-processed before we send it. So all these things comes under this pre-processing. The next is this feature engineering. So this is a process of extracting meaningful information from the raw data to make it usable for the machine learning models. So it converts whatever the raw data into what the machine can learn. So the next is the modeling. So here you have to choose a model which is appropriate as per our requirement. So once the model has been chosen, we evaluate the particular model. So based on the evaluation of the model, if the model is proper, or if it is not proper, we have to improve the model. So what we do, again, we do this cycle, pre-processing, then the future engineering, then we choose the one more model, and then we evaluate. So this cycle repeats. So once we have got the appropriate model and evaluation is proper, we deploy the model. So once that deployment has been done, we monitor and model and update the model. So like this is called the training of the model. So this is how our data processing happens in NLP. So the next will be continued.
Thanks, Chandana. So this is the topic we have to be continued, the automation challenges and solutions, which is the robot framework. Let's start with the introduction to the robot framework. As you all know, even a layman can understand this robot framework syntax, and it's very simple to use. So currently, we have the test data, which is the test data syntax, then the robot framework. So in the backend, we have the test library APIs designed for the running of the robot framework. Then we have the test libraries such as Selenium and Swing. And also the final thing is the application interfaces. So the application interfaces here, it's the system under test. So it is the system where we are implementing the test case and executing. So this is the sample RFW, the robot framework sample test case overview. So in the settings section, initially we would have a documentation thing wherein that would represent the exact intention of the test case. Then we have the library. So library, usually it will be the .py files. For example, in this case, we will be using a calculator library. And next part will be the test cases. So here it will be the high level case wherein what the user has to do and what he wanted to achieve it. So like it's a sample addition test case. Basically, if you see given calculator has been cleared. So when the user types an input and he pushes the equals and the result is 2. So basically this will be followed up by the keywords. Keywords are nothing but the test steps. So it will be for the user or a new person to understand once he uses these keywords in this format. So as we can see, the first step would be like the calculator has been cleared. So here the user pushes the button C. Then user types. So next, the typing will be done by the user with an expression. Then once that expression is like 1 plus 1, so he pushes the button equal to, and the final result would be the dollar result would be the 2 value. So overall, this is the format wherein a sample robot test case can be written using an enormous amount of libraries, and the syntax is very clean. So let's go through here. What are resources and variables? Basically, the resource and variable files are used for scalability by maintaining reusable code. Usually the test case when we are writing, so it might become clumsy. So if we have the resource files, we can just import those resource files in our test case and try to execute. So variables are used as follows. So unlike other programming languages, we have the list variable, which is an array, so denoted by @var. Then a dictionary variable. Usually a dictionary variable will be a key value pair. So if you see here the ampersand with the variable, so this is the syntax. Then we have the built-in variables like current directory and execution directory. And also sometimes we would have the runtime variables like the debug file and the output directory. So basically it depends on the user requirement and his input. Let's go to this conditional access in the robot file. So first and foremost, we have the tags. Tags is like a very generic purpose to identify the test case. Like say if we have a particular feature ID, so that denotes the test case, and that would be treated as a different from other features. So that more likely tags are helpful in that case. So usually we use the force tags for the test case writing. So then we have the conditional access like if, then else. So again, it depends on the user conditions, wherein when once the test case is written, based on his requirement, he can have a if condition, like say if the first step fails, just skip to the third step or to the next step. So such kind of statements are easily available and used within the robot framework. Then we have the run keyword if, then run keyword unless kind of conditional access. Also, we have some types of like skip if, skip. So basically, if at all we want to skip a particular step and just navigate to the end result. So everything is accommodated here. So this is a very clean syntax in the robot framework. Yeah, as you all are aware, yeah, so why we are like dealing with AI and ML concept? Basically, it is to solve our real world automation problem. So basically, so some of the solutions which can be given for these problems are like auto-identifying keywords in the robot framework. So here the natural language processing help would be taken, and we will be using that as well. Then preparing data set accordingly. So this also involves the machine learning concept. Also, the user needs to provide the input steps. So it would be as per the user requirement, what he exactly needs, which is called as the training data. Then keywords will be automatically fetched from the dataset. So overall dimensions, what we can see is the robot framework, the NLP, and the combination of artificial intelligence just smooths the user experience. This is the sample flow wherein the steps are involved. Once the user has a text file as an input and he gets the robot test case as the output. So let's begin with the first process. So the first process is tokenization. So tokenization here, the large chunks of data, basically the unstructured data, the natural language text will be converted into huge chunks of data, and it would be of discrete elements. For example, a text like a data string can be converted into numerical representation, which is easily understood by the machine learning language. Then we have the feature extraction. So here in the feature extraction, basically whatever the numbering we would have given from the output, which is the system has received, so the additional weights would be assigned in this feature extraction process. Then we have the model training. So the model training has a lot of different models which has to be used by the user. Basically, some three types, if we can tell, is like first we have the text classification, then question answering, then machine learning translation. The next process would be the fine-tuning. So basically in the fine-tuning process, the computer or the system understands the converted data, the machine language data, and processes it. And also it's a process of retraining the pre-trained data and using the user's custom values.
Then the next step would be the model specialized to target data or task. So here in the backend, so it will be identifying the required data and that will be used here. And further, the data obtained, if it is a valid one and the proper one, then we would have the user would receive the valid output as the robot test case output. Else, if there are some issues with the user output, then again the process is continued with the pre-process and cleaning, wherein the unwanted data and text is removed here. And again, this overall processes follows up, and again the entire processes leads into the robot test case output. Conclusion. So yeah, what artificial intelligence is doing. So basically, if you can see, artificial intelligence and robot process automation and machine learning can transform time-consuming and error-prone manual tasks to automated ones, which is very more likely in the real-world scenarios, and streamline for simplicity than improving end-to-end service. Intelligence also needs to be smart to drive the change, and no person wants to write a huge lines of code and worry about it. And also, implementation needs to be powerful enough to coordinate the responses and adaptations. Summary. So basically, whatever solution we have given here, so we are using in our Nokia products. So as we know, Nokia products mainly deals in the technologies like 2G, 3G, 4G, and 5G, where a lot of regression test cases has to be done to ensure the quality. And this would be of like multiple features and over 200 to 300 test cases. So those things cannot be manually done. So the automation is the key here. So this solution or the tool simplifies the efforts spent in creating the test scripts to execute test cases. Even the customer cases can be automated faster with the help of this solution. So for our users or all the people, these are the references for the robot framework guide. So these are the references which can user can check and utilize in his daily test case execution or his implementation using the robot framework. Yeah, thank you.
Okay, thank you very much. Do we have any questions? If yes, please raise your hand and then volunteer will approach you. Okay.
As I understand, this tool is already created. Is it possible to see some like proper examples of its usage? Or
Yeah, actually, this is in a beta version, so still we haven't. We are actually doing a lot of testing here. So it's in design phase kind of a thing. So beta version is still ready, and we are just doing a testing over here. So once it has been completed, then maybe we could do it. But right now, it is not possible to show any demo.
Okay, thank you very much.
I guess there are no more questions. So thank you very much for this online transmission. And thank you, people here on the in the room. Thank you very much once again.
Thank you.
Thanks a lot. Yeah.
Okay, and from the organization things, please remember about the arcade tournament in the room number 8. Also, please remember that there's an envelope contest, that there are envelopes hidden somewhere. So for now, we have half an hour of break. The next lecture starts in 30 minutes. So please go outside, grab your coffee, straighten your legs, and see you later. Thank you very much. Good afternoon, once again. Welcome in the room number 7 on the 9th Code Dive conference. We are in Kino Nowe Horyzonty in Wrocław, and our conference is organized in the hybrid mode, so please take your seat. Please mute your phones during the next speech, and have fun. After the speech, there will be time for 2-3 questions on the Q&A session, so please raise your hand, and our volunteer will come to you, give you the microphone, and you will be able to ask the question. Okay, so it's time for our next speaker. Our next speaker, Remigiusz Marciniak. Remi is a software engineer at Nokia. He doesn't have a long professional experience. However, he is a real IT passionate. He holds Master of Science in Big Data Analytics, and he's an engineer, and he do it by studying medical informatics. In his free time, if Remi is not working out at the gym or spending time with his friends, he must be learning new things. Among them are economics, business, business management, and IT. You can stay in touch with Remi on LinkedIn, and he will provide the QR code later. Remi, come to the stage. The stage is yours. Good luck.
Hello, everybody. Can you hear me well? Raise your hands, the last row. OK, thank you. So, hello, everybody. I am really happy that I can be here and present to you. Can we, because it's not visible on the slides? OK. Thank you. So, I'm really happy that I can present to you this interesting topic, which is an insightful analysis of artificial intelligence in telecommunication sector. My name is Remigiusz Marciniak. It's a Polish name, so it's quite complicated, so I will say it once again, Remigiusz Marciniak, but you can call me Remi. A few words about me. Thank you, host, for the really nice welcoming. So I am a Master of Big Data Analytics and Medical Informatics Engineer. In my free time, I like to volunteer. Here on the left picture, we can see me in Śnieżka mountain in Poland. I was cleaning the mountain trails there. And the presentation plan for today is that on the beginning, I will, of course, present the main topics of our presentation. It will take around 45 minutes, and then there will be time for question and answers. And finally, there will be time for lunch break, for which I can't wait. And what are the goals of our presentation? So first of all, I want to show you artificial intelligence use cases in telecommunications. And then I want to show you the impact that they have on our daily world. And I want to inspire you to take actions to change our world. And I have 3 key messages for you of our presentation. So the first one is that AI thrives the development of telecommunications. The second one is that AI applied to telecommunications can change our world. And the last one, and most important one, is that you can change the world. The roadmap for today, for the presentation, is that on the beginning, I will tell you something more about telecommunications and artificial intelligence. And then I will move to use cases of AI in telco. Eventually, there will be time for summary and conclusions and Q&A. And of course, lunch. So to begin with, what is the telecommunications sector? So the telco sector is made up of all telecommunication companies, telephone companies, as well as internet service providers. And the second fact, which is more important in my opinion, is that it plays a crucial role in the evolution of mobile telecommunications and the information society in which we live nowadays. I have found 2 inspiring quotes. This is the first one by the company Deloitte. It states that the telco sector continues to be at the epicenter for growth, innovation, for almost any industry. And the mobile devices and related broadband connectivity continue to be more embedded in our society. And I think that we all can see this, that we need to feel connected to the world, to the internet. So it's really important for us, for the society. And many other services and sectors develops because of the telecommunication, for example, video streaming, IoT, and mobile payments. The second one is by Investopedia, and it states that the telecommunication is the world's biggest machine. And there are devices which are connected together, for example, telephones, mobile phones, and of course complex networks and PCs. And this system touches nearly all of us. And I think that we all know that this allows us to speak, to share thoughts, and to do business globally with nearly anyone on the globe. And of course, telecommunication companies make this happen. I think that you will find those quotes inspiring. So we can illustrate the telecommunications as many devices, as the complex systems with many devices, such as antennas, servers, databases, satellites, and so on. And of course, we can't imagine this system without telephones, mobile phones, smartphones, routers, and many other devices. And the fact is that this system generates an enormous amount of data every second. And of course, artificial intelligence can do something really useful with this data. Now I want to tell you something about the history of mobile communication. So in the 80s, we had analog voice, and we weren't able to transmit any more data. Then in the 90s, we had 2G, so second generation, and digital voice, text messages, and slow and expensive internet. Then there were time for 3G and high wireless connection, and it was in 2000s. And then 2010s, the era of 4G and faster networks. And now it's the era of 5G, so 2020s, and the idea that all devices are able to connect to the internet. And talking about the history reminds me of the old times. And the old times are the Nokia phones. And now I want to state something really important, that nowadays in Nokia, we don't produce phones anymore. We create sophisticated IT solutions and networks. And I have a surprise for you, because I have this old Nokia phone with me. You can see it. You can even touch it if you want. It's real, right? And I want to check if it's true. So I will drop this phone. Are you ready?
Yeah, go for it.
Oops. Well, the phone is okay. I mean, the screen is okay, so it works. So do we have any volunteer for the new iPhone? Any volunteer? No? Okay. And of course, I hope that this phone won't vibrate in my pocket. And we can think about the future. So what the future will bring. And the 6G is the future. And the main trends in 6G are UAVs, so unmanned aerial vehicles, satellites, artificial intelligence, of course. And later I will show you why. Energy efficiency, which is really important nowadays, and virtual reality, augmented reality, and new spectrum. And what are the values generated by the sector? So the first one is that this fact that I said, that it satisfies our basic needs. So we can feel connected, we can be in touch with nearly anyone on the globe. It's crucial for security in many ways. For example, many sectors such as healthcare or banking rely on telecommunications, so it's really important to take care of reliability of telecommunication networks, and I have a really interesting use case which I will show later. And of course, it boosts economy, so we can do business with nearly anyone on the globe. And our communication is improved, it's more efficient, it's more flexible, so we can, for example, work from home, we can be flexible. And of course, the collaboration is improved. And there's another funny picture. This bird on the right has Wi-Fi, so wireless connection. And now I want to say something more about the global telecom market and about the growth of it. So we can see that from 2021 to 2022, it's 9% of development. And in 4 years, it will grow by 26% more. So it is a really, really huge number. What are the challenges of the sector? Because there are many of them. The first one is energy efficiency and green energy. So we can see the trends in the nowadays world that green energy is the future, and also energy efficiency. The next thing is the network security. So we can see many threats which are in our daily world in which we live, and of course they are the threat to the networks. The next thing is generating massive amount of data. So we can see that there are many data generated every second. And we may take advantage of this fact. We may apply some artificial intelligence methods, which I will show you later, and create a really, really good value with this data. And the last thing is that the demand for traditional service is decreasing, so customers want innovation. And I have a question to you. How many of you know artificial intelligence? Raise your hand. Okay, so there is some of you. Nice. And now I want to briefly explain what is artificial intelligence. So it is intelligence which is demonstrated by machines, such as computers, as opposed to the natural intelligence which we, beings such as animals and humans, have. And the second fact, the second term, states that this term, artificial intelligence, is frequently connected with cognitive skills that are associated with our human mind, such as learning, problem solving, the ability to reason, discover meaning, generalize, or learn from past experience. And I think that you know those three terms, which is artificial intelligence, machine learning, and deep learning. And the relation is that the machine learning is a subset of artificial intelligence, which is focused on creating a solution which solves a task without explicitly programming the rules. And deep learning is a subset of machine learning, in which is focused on artificial neural networks. And neural networks are, of course, in beings, in animals, in humans. So it is also inspired by the nature. And there are main four machine learning types, which is supervised learning, where the data is labeled, unsupervised, where the data is untagged, and reinforced, where the main idea is that there is a model which tends to maximize the reward for solving an issue. And the last one is semi-supervised learning, which is a combination of the first one and the second one. So some data is labeled and the rest isn't. So the first task is classification. So briefly speaking, a program must draw a conclusion from observed values and determine to what category an observation belongs to. And I have a funny example here. So the task is to classify the images as dogs or muffins, and of course, how to confuse machine learning. So this is the first example, and I also feel confused because some of the pictures looks the same. The second one is regression. It is also supervised learning, and the main idea is that the program, the code, must estimate and understand the relationships between variables. And this analysis focuses on dependent variable and a series of other changing variables. And I have another example. So this is a chart of reported happiness as a function of income. The thing that we all probably know and think about the happiness and income. So on the x-axis we have income in thousands of dollars, and on the y we have happiness score. So if we don't look at this line, we have data points which are, let's say, we have a mess there. And if we apply regression, for example, linear regression, then we can have a line, and we can predict or even estimate the value. So, for example, let me assume that we don't have the happiness score for $50,000, and then we can look at the line and we can see the happiness score, which is of course predicted. The next is unsupervised learning and dimension reduction. So Briefly speaking, it reduces the number of variables which are being considered to find the exact information required. So we can imagine that we have a table, which is our data set, and we have columns, which are features, and for example, we have 10 of them. And we want to reduce them, and we can, of course, do it. And here is the example. So we have, for example, three dimensions, 1,000 points, and we can go to 2 dimensions with 100 points, and then to 1 dimension with 10 points. But the most approach is that, for example, we reduce from 10 or maybe 5 to 2 dimensions. And another technique, which is slightly connected with this previous one, because it's often used for clustering, is clustering. So it involves grouping sets of similar data, which is based on defined criteria. And it's useful for segmenting data into several groups and performing analysis to find patterns. So here I have the example. There are two dimensions, and we can see that there are the groups. There are the cities in the United States, and they are grouped. And here I think that there were applied the k-means algorithm, and we can see that without any expert knowledge, the groups were created. And here I have a brief comparison between machine learning and deep learning. So in machine learning, the engineer extracts the feature, and in deep learning, it's done by the network. So this is the main difference. So now I want to present you use cases of artificial intelligence in telecommunication sector. So the first one is transitioning from rule-based systems to machine learning-based systems. So on the left, we can see that there is a system which is rule-based. So we have rules which are created manually by the engineers. And on the right, we have transitioned to the artificial intelligence, to the machine learning-based system, in which the rules are encapsulated in the model. And the facts are that the manually created rules do not scale to capture complexity of today's and futures networks. And the second fact is that AI models provide insights into correlation and causation. And the last fact is that AI can capture the behavior of the network, which is only apparent after processing large amounts of data and, of course, complex data. As I said on the beginning, we can only imagine how many data is generated by the telecommunication sector. And we can, of course, gather this data into a data lake, and then we can apply anomaly recognition. So we can detect anomalies, which is really important for network reliability. And of course, if you have many data, then we can represent the data, for example, as a graph. And then we can see, for example, if the network is overloaded, if there are some problems with the network, or if the network is functioning normally. So in general, anomaly detection helps us to detect issues and retrieve their root causes, and of course monitor them in graphical user interface. We can annotate newly discovered network issues using the domain expertise that we have, and also insights from AI models, from the complex and enormous data. And of course, we can continuously adapt and add the new issues and fix them. And in general, about the network performance monitoring, so we can apply unsupervised machine learning where no expert knowledge is needed, because it is done by the model, by the algorithm. Of course, we can identify anomalies, which is important, and I will show you in a moment why. Multivariate relationships can be understood, and proactivity, so detecting anomalies before they escalate to severe problems. And now I want to show you a really important example. So in Canada, there was an outage of the company called Rogers Communications, and it lasted for around 1 day. and around 25% of Canada lost internet connectivity, so over 12 million subscribers. And unfortunately, most of cellular services were affected, including 911. And here is the gap, and we can see that it looks scary. And what was the impact of it? Why it's important to detect anomalies and to act and to react? So it affected governmental services such as Service Canada, Canada Revenue Agency, and of course passport offices. And the more important fact is that medical appointments were rescheduled for oncology patients. So we can see how it is important to monitor the network. And of course, debit cards weren't accepted, so many stores, many companies lost money. It was estimated from a few hundred to several thousand of dollars. So we can see how it is important to monitor the network, and of course, artificial intelligence can help. And I have another question to you. Do you know this guy? Raise your hands if you know Buzz Lightyear. I really like this animation. Toy Story is really nice, and I show you this really nice guy because now we'll move to some extraterrestrial topics, to some space-related topics, namely to the artificial intelligence for satellite communication. So the first fact is that satellite communication offers us the prospect of service continuity over uncovered and also undercovered areas, also service scalability. And the second fact is that artificial intelligence is growing as a research field, and of course it has many applications for satellite communication, which I will show you in a moment. But firstly, what are the challenges of satellite communication? So first of all, resource management. They are expensive. Network control, network security. We need to care about some anti-jamming techniques in order to let the network be reliable. Spectrum management, and of course, energy usage, which is, as we all know, important. And there are many use cases of AI for satellite communications, but I will show you some of them. For example, beam hopping, anti-jamming, space air-ground integration, interference management, and ionospheric scintillations detection. The first one is beam hopping. So we have a mismatch between requested and offered resources, and to cope with this problem, we can apply beam hopping techniques. And there is an example of this architecture. So we have this resource manager, the telemetry tracking and command center, and then we can send to the satellite the beam hopping illumination pattern, and we can then provide the service which is, of course, fitted to the requests. And of course, AI can help us with that. So we can model this problem as a Markov decision process to optimize the transmission delay and the system throughput. And of course, we can use deep reinforced learning to solve this beam hopping illumination design. And the fact is that this proposed model can reduce the transmission delay up to 52%, which is a lot, and increase the system throughput by up to 11%. Another technique is space-based anti-jamming routing. So we can see here that we can do the routing, which is anti-jamming, which works in the anti-jamming way. And AI can be applied to help it. And in general, as I said, reliability and security is important as well in satellite telecommunication. And jamming attacks can be, they are a really, really high threat because they can even paralyze the throughput of the network. And AI algorithms are double-edged sword here because they can help and they can also perform intelligent attacks. And for example, long short-term memory networks are used to learn the temporal signal, and then the results are that the synchronization time is reduced, so it's good. And another use case is space air-ground integration. So we have the ground infrastructure, which is connected with the air, so with the UAVs, balloons, and other vehicles. And then we have satellites in orbits. So this is the space air-ground network. And we can use convolutional neural networks for the routing problem to optimize the performance of the network using traffic patterns. We can also use deep reinforced learning to the source satellite UAV association and the location of UAVs. And the fact is that those methods achieve up to almost 6 times higher average data rate than a direct communication baseline in the absence of UAVs and satellites. Another use case is managing interference. So here we have 2 techniques, which are antenna adjustment and satellite selection. And there are many techniques to minimize the interference. Some of them are SVM, so supervector machines, unsupervised learning, which was mentioned many times in this presentation, deep reinforced learning. And the second thing is that we can do automatic real-time interference detection by using LSTM. So we can gather the data, the historical data, which is free of anomalies, and then we can compare it with the received signal and with the design metric to find anomalies. And the last one, I think, is ionospheric scintillation detection. So in the ionosphere, we have free electrons, which can distort our signal, and we want to mitigate this problem. And we can use SVM algorithm to detect amplitude and phase scintillation. And there are 2 use cases which uses decision trees. The first one uses decision trees and random forest to detect ionospheric scintillation events, and the accuracy is almost 100%. So it's like the level of human-driven annotation. So it's a really great. And the last one is the second use case also has 96 of accuracy, which is much. And another question to you. So how many of you care about the natural environment? There is a lot of you. And I'm asking because now I have the BTS power saving algorithm, and it will be about energy efficiency and energy saving. So in Palestine, in Gaza Strip, there's a district which is called Gaza Strip, and there is energy deficit, and it affects all industries. So there's a need to optimize and reduce the power consumption of the network. Yes. Okay, so I see some problems, but it's okay. Yes. And the model helps GSM radio frequency engineers to choose the optimal value of parameter for BTS saving algorithm, which aims to switch off unused frequency channels. And this model uses K-means algorithm, which is based on unsupervised machine learning technique, clustering. So it looks like this, that we have 3 dimensions, and we can cluster the GSM cells. And we see here 3 clusters, and by doing this this approach, we can on the left we can see that we have a constant value of this parameter, and by using this clustering technique, we can fit this to the real traffic. And the results are that the power consumption has been reduced by almost 21% by the proposed model, which is really, really much. And the second thing is that this model has been deployed and tested on a real GSM network, which is amazing because we can see that this works. And there are many other use cases, for example, traffic forecasting, server occupation, virtual topology design, path computation, and intruder detection. So we are coming to the end of the presentation, and I want to do the summary and conclusions. So there are many places where AI can be applied. AI will have a great impact on the next generation wireless networks, 6G, for example. And this sector generates enormous amounts of data which can be used in artificial intelligence. Power consumption optimization can reduce the network running costs, so the energy efficiency. And another fact is that telecommunication sector is crucial for many other industries, such as healthcare and banking. And lastly, reliability, security, high availability, and proactivity can be obtained by the application of AI. And of course, maybe I can use this Nokia as a hammer, because as we can see, it's really reliable and strong. And now I want to once again say the key messages of our presentation. The first one is that AI drives the development of telecommunications. The second one is that AI applied to telecommunication can change our daily world. And the last one is that you can change the world. Thank you very much for your attention. Feel free to add me on LinkedIn. Thank you very much.
Thank you, Remi. So now it's time for your questions. Please raise your hand if you have any questions to Remi. Okay, Remi, I guess there are no questions. So
time for lunch.
Thank you once again.
Thank you very much.
Thank you. We have a small gift to you. Remi, you can sit down. And last logistical information. Right now we have a lunch break, so see you in an hour. Feel free to go outside and eat something delicious. Thank you very much for your attention. See you later. Hello, once again after the lunch break right now. I hope that you have a lot of energy for our next lecture. From logistic things, after this lecture there will be a coffee break, so feel free to attend it. And the Q&A session will be held after the lecture too. So if you will have a question, please raise your hand and our volunteer will come to you with the microphone. Okay, without further ado, Aleksander Augustyniak is our next speaker. Aleksander is a software developer at Nokia. He started his programming adventure over 10 years ago, learning Pascal, then C++, and assembler for PC. He's an author of C++ app to detect eye blink on a selfie, painting app on assembler for PC, and many other solutions for PC and PLC, including 5G deliveries at daily work. Aleksander has experience as a programming and algebra tutor. He likes the game of bridge and survival. Ladies and gentlemen, Aleksander, good luck.
Hello everyone. Hello, today we are going to talk about lazy initialization, and we are going to start to talk about what it exactly is and how we can use it. And we are going to dive into some implementation, some really simple code, and I tried to write some very basic example to make it as understandable as possible. So what lazy initialization is? Lazy initialization is delaying creation of an object until the object is used, and it also can be delaying of some heavy computation until the result of this computation is needed. How we can use it? The widest usage of this pattern is unit testing, where we create some mocks and some dependencies of system under test. And in some cases, this delaying of initialization can result in delaying it until the end of program. So that means the object is not created at all, and we save some resources. We don't have to do any calculation connected with creation of an object. And our program runs faster. Yeah, and we just save resources. Moreover, it can be used in production code. For example, when we create some heavy databases, objects, and we don't need to create all database until it's used. For example, in some gaming, we can only create objects which are visible for the camera or player or car, for example, when we play some racing game. And yeah, and basically this is it. So lazy initialization is deletion of creating object until the first use. Oh, sorry. And we are going to start with some very basic examples how to implement it, and more complex example basically have this basic example somewhere behind, and more complex examples are wrapper over it. So the simplest way to let's let's have some subclasses which print something when it's constructed and prints something in some method, and it's just as simple method as it can be to show some action connected with this object. And I wanted to sort sub A class and sub B class just to have two classes. Yeah, and we have a lazy class which uses classes like this, A, B, and C, and C is equivalent of subclass A, subclass B, and subclass C. They just print something when they are constructed, and they just print some other thing when they are used. And here we have simply these objects, and lazy also works like this. Lazy uses A, B, and C objects and have constructor which prints something when it's constructed. Yeah, and here to see how lazy works, we have empties. And do you know why it's empties, like module test, not unit test? This is module test because we use original implementation of subclasses. We don't mock A, B, or C. And it works like in test object is created in each test if. So it's just basic G-test things. And this class don't have lazy initialization, so it should print in each test subclass A constructor, subclass B constructor, and subclass C constructor. So going back, in first example, we create object of lazy class, but we use only A class. But object of B and C class also is created, but it's not used at all in this test. And the same thing is with test of B class. Only B class is used, but we create also A class and C class. And first way to achieve lazy initialization is using of raw pointer. And I don't recommend this way of implementing lazy initialization, but it is the most simple way. So instead of using simply object, we are going to use in our lazy class a raw pointer to the sub A class initialized with null pointer. And what are the drawbacks of this solution? We gotta use explicit delete of A class, and we gotta implement A with new statement. And other drawbacks is we gotta have a destructor of lazy class. So that means we gotta put some effort on applying the rule of 5 implementation. So the rule of 5 means if we have destructor, we also gotta have copy constructor, copy assignment operator, move constructor, and move assignment operator. And it's not the end of the world, but we gotta put some more effort on implementing this. And here, as you see, we also have to check if object was already initialized. And if not, we create this object, and then object is used. And if object was created before, it's simply used, and we don't create other object. So it helps us to delay creation of this object. And in our test, the same class, when we test A, as you see, we have subclasses of lazy constructors because they are not lazy for now, and they are constructed before the constructor of lazy class. After subclasses are constructed, and they are fields of lazy class, as you remember, lazy constructor is called, but sub-A constructor, it's called right before usage. So if we could go back to the lazy class, one slide. If we replaced here a field by pointer to sub-A class, sub-A class constructor, it's not called before constructor of lazy class, but it's called right before usage of A class. And if we don't use A class, for example, we call class which uses only sub-B stuff, as you see, constructor of subclass A, it's not called at all, and the object of sub-A class is not created, and we saved our resources. In this example, it's not a big advantage because the object is very light, but if a sub-A object is heavy, it can be huge advantage. Yes, and as I mentioned before, the drawback of this solution are explicit usage of delete and new, so we have to manage the memory manually, and there is a risk to forget something, to do something wrong, and in huge projects it's not recommended. And the other thing is some extra effort needed to apply the rule of 5. And more safe option, and I think the option recommended by default, could be smart pointers. And you can use either a unique pointer or shared pointer. The difference is unique pointer can have only one copy, and shared pointer can be shared between between a lot of variables. And I used unique pointer in my example, and it could be a shared pointer, and I think it's even better to make it shared pointer. And we can use smart pointer in the same way as we are using the raw pointer. Simply before usage of the object, we have to check if object was initialized before. If it's already initialized, we simply use it, and if not, we have to create this object and then use it. And if we have, like I mentioned before, some simple unit test or module test from GTEST, and here it is a module test because we use original implementation of B. The effect is like this. A constructor of sub-B class, it's called after constructor of lazy class, so lazy class is created without creation sub B class before, and we delay construct of sub B class until its use, and it's created right before first usage, and if B class it's not used by this lazy class or class which uses the sub B class, this object is not created at all, and we only create objects which are not lazily initialized. The other way of the other simple example of lazy initialized object is usage of std optional, and we initialize the field with empty optional instead of object, and we gotta check if an optional has a value. Then if it has a value, we can simply use it, and if not, we have to emplace this object, and this function basically calls a constructor of sub B object, or the object which is wrapped by std optional. Yeah, and you have to remember to check if it's already created, to not crash the program. This is a drawback, but advantage is we can delay our creation of this object. Yeah, and in this example, as you see, only lazy constructor is called, and now neither sub A, sub B, or sub C object is created. All of this object now waits till the first time they are used. Yeah, and B class, it's construct only if B class is used. C is construct if C is used, and those objects are not created if they are not used. And what's the difference between smart pointers and std optional, and when one or the other option is please excuse when those options are better? The main difference is smart pointer allocates the memory for the object on the heap, and std optional allocates the memory for an object on the stack. So the memory is occupied a little bit longer for std optionals, but we have faster access to this memory. And I recommend std optionals, for example, when you test with mocks, when you test some class with mocks of object which are fields of system under test. And in such cases, fields are created before the constructor of a class under test. And you don't have an opportunity to set expect calls for those constructors. And you can solve this issue by using std optional and delay construction of class under test after setting those expect calls. And if you know gtest works this way. Each test has a constructor of test. Each test has a setup method and teardown method. And those functions are called every time when we have some test in gtest. So, for example, test class can have a class under test field, and it can be created in constructor of test class, and before it we can set some expectations for those constructors. Okay, and let's look at some more examples with basic utis, and I tried here to do really utis. So here we have basic mock, and to make it a little bit easier, I didn't use mocked object as a field of tested class, but here I showed some dependencies. So y and x, which are constructed in a similar way as before, are simply dependency which are injected to a lazy constructor. And to mock class y or class x, we gotta have a virtual function for it, and also I guess okay, we have virtual function, and this function is mocked here in mock, and in test we have test of this lazy class. We creates mocks and search pointer of mocks to compare a lazy initialized mock with not lazy initialized mock, and if we use we set expectations on the mock x to doing some stuff, and using our lazy class, we are using method which uses X object, and we do similar stuff with Y class. But here we're creating mock Y only here in test of Y. And the result is not lazy initialized class is constructed in both cases, in both tests, and Y is created only in test which uses the class of Y. And now let's jump to some more advanced example. So only to summarize what we have until this moment, the basic ways of lazy initialized object is using of raw pointers, smart pointer or STD optional. And more advanced example is using of proxy design patterns. And you can use under this design all of method mentioned before. So what is proxy design pattern? We have this pattern where a real object which is created and our proxy wrapper implements the same interface. So the interface must be the same. Each method must have the same name and the same arguments, and they can derive from some interface or simply have the same interface. And proxy before calling any method from real object can check if object which is under the proxy was created before or not. And if not, it creates this object. But here it's not only in one place, but it checks if object was created before in each method in the interface. So I think key takeaways from these presentations, I think, is to remember that lazy initialization is delaying of object creation or delaying some heavy expensive processes until they are needed for the first time, and basic ways to achieve it. For example, to use raw pointers, smart pointers, or STD optional. And I recommend by default using smart pointers and using STD optional for unit testing when you have to set some expect calls for on creation of fields of system under test. In some languages, we also have some wrappers to not create manually object. Like, for example, C# has a lazy wrapper on object, and you can also do it manually, but by yourself. And these wrappers simply uses real objects and creates this object before its first usage. And okay, and I think basically this is it from me. And do you have any questions about the lazy initialization? Yeah.
Aleksander, I guess there are no questions.
Okay.
Because I can't see any hand in the air.
Okay, thank you.
Okay, so
I tried to make these examples as basic as possible to help understand people who begins their adventure with it. Understand it better and understand the basics of it. Yeah, and I hope it will be useful for you. And thank you for your attention.
Okay, and thank you for that, Aleksander. Thank you.
Thank
we
you.
have a small gift to you, for you.
Yeah, thank you.
Okay, and thank you all for your patience. Right now we have 30 minutes of break, so see you here in 3:20. Thank you very much. Hello once again after the break. For those who are watching us online, we are in Wrocław in Kino Nowe Horyzonty, and this is the next Code Dive edition. Before we will start with our next speaker, please mute your phones, because we don't want any interruptions here, because it's kind of disturbing to our speakers. And please also don't talk as much during the lecture, because it's also very hearable and it can be a little bit disturbing. So thank you very much for this. Okay, and our next speaker is Natalia Lewków-Pankiewicz. Natalia has been working in requirements engineering for 8 years. She is not only actively writing specification, but she's also contributing to Nokia Mobile Networks specification standards and processes development. She will introduce us today to the basics of what the specification is and how to do it right, based on the worldwide standards and real-life experience from her daily work. Natalia Lewków-Pankiewicz, the stage is yours. Good luck.
Hello, everyone. Thank you very much for showing up. I will be talking today about requirements engineering, about specification, considering whether it's a waste of paper or maybe a tool that can help you to effectively manage your project. A few words about me. I've graduated University of Wrocław, computer science. I have 9 years of experience in Nokia. In current role, I'm a system architect of one of Nokia Mobile Networks specification teams, working on operations, administrations, and maintenance of the base station containing 2, 3, 4, and 5G radio access technologies. Privately, I'm a house plant freak. I have probably over 500 plants. I have stopped counting at some point. I love animals. I have 3 cats and 2 aquariums, 1 saltwater and 1 freshwater. Agenda for today, for the next 45 minutes, is firstly to introduce you to why this topic was selected. Then I will tell you what specification is, what is the requirement, so a bit of definitions. Then who needs specification, what are the consequences of not investing in the specification, how to start writing specification for your project, what are the characteristics of a good requirement, how much does the specification cost, and at the end, summary, your questions and my answers. If you search the internet looking for specification memes, you won't find many, there are just few, but they are addressing the problem quite well. So let's remind this popular joke about customer expectations versus the reality of the IT project. I hope you can see it. So this is how the customer explained it, the feature, how the project leader understood it, how the analyst designed it, how the programmer wrote it, how the business consultant described it, how the project was documented in the original of this picture, but I would add here also specified, what operations have installed, how the customer was built, how it was supported, and what customer really needed. That's unfortunately reality of many IT projects. They don't have documentation, they don't have specification, or even if they have, it's highly unpopular to use it. I remember when I was a software developer for a brief moment in my career, my senior teammates told me that specification is a waste of paper. Because it's too high level, it doesn't help the developer to do their job. They didn't even bother to show me where to find that specification, or didn't bother to really think about what they can do to improve that situation. Perhaps develop more levels of that specification so it's more detailed and more useful for them as well. Before I start talking about specification and how to do it right, it's important to understand the difference between the specification and documentation, because they are very frequently mixed. Both are talking about how the feature works, right? But specification is done at the beginning of the feature development cycle. It's really designing how the feature is going to work. And documentation is done after a piece of software is developed. Again, going back in time, before I have joined specification team, I thought my English is not good enough to be a specification engineer because I've obviously mistaken specification for customer documentation. While in customer documentation, it's really important that the language is good and the text doesn't contain typos. In specification, it's not that important as long as it's understandable and unambiguous. Specification is a set of requirements. Requirement is something needed or wanted that can be expressed in multiple forms. All of them have a common denominator. They need to clearly state what is required from who, when, and why. I will show you 3 examples of forms of requirements that I'm using in my daily work. That would be user story, single line requirement, and user scenario. 2 first ones are quite short. You can see kind of a template here on the slide. User scenario or a use case. There is a slight difference between those 2, but that's just for your overview as an example, so let's not go into the details. User scenario is describing in steps also who does what and when, but in a wider context of particular scenario. It can be in the form of a text or a diagram. On the next slides, I will show you some examples so that you get an overview how specification can look like. Let's start from the user story. On the top of the slide, you can see a template. On the bottom, example. The red highlighted part is indicating the requestor of the requirement. The purple one is the actor from which something is required. Yellow part is about the requirement itself, what is required, what this actor needs to do. And the last part, why. So the justification, the rationale behind the request, behind this requirement. I have selected, I hope, universal and simple example. As a customer, I want web shop to display login option for not logged in users so that not logged in users cannot see the web shop content. If you have ever used Zalando Lounge, this is how it works. You need to first register and log in before you can see what is in the web shop, in the web store, or buy anything, right? That's the first example. The same requirement in the form of a single line requirement could look like this. When a new web shop HTTP session is started by not logged in user, web shop shall display login option. You may notice that this rationale part is missing. So it's nice to have it, and it's nice to add it as a note aside of the requirement to explain why something was designed in a certain way. After some time, you will not remember in all the cases why something was designed this way. Sometimes, not in this case, it could be some hardware constraint that you are forcing you to design something in a certain way. Sometimes it could be just a temporary software limitation because you want to save efforts. And in the future, you can improve the functionality, you can improve your design. So it's good to have this note. All right, you may also ask why this strange shall is used here. Shall is not only a word here, it's an icon. It is screaming that, hey, this is a requirement. It has exactly the same meaning as must, but somehow sounds stronger, right? One of the mistakes I have seen is that instead of shall, people are using should, may, needs to, and those are not binding. Shall or must are binding. They are made for writing requirements. Also, a trap is to use will. Sometimes people, when writing requirements, think about how it will be designed in the future and use will. But at the moment of the requirement verification, it needs to be stating the current state. It must be about the presence. All right, and here, the example of user scenario, quite longish, but the scenario is very simple. It contains certain sections. You can see a template on the left-hand side and the example on the right-hand side. User scenario is about webshop first launch. It has description that is explaining the background of the user story and describing what the user story is about. It can refer to other related requirements, give some background information. For example, this user scenario describes first launch of webshop application. For logged-in user webshop launch, please see user scenario number 2. Next part, actors. Those could be passive actors, like those that interact with your system, like user, web browser, and your part of your system, actors from inside of your system, like webshop. All the parties that are playing role in the scenario. Then preconditions. Those are assumptions you make before this scenario starts. User is logged out or never logged in. Triggers. Those are states or actions, one or more, that could trigger this scenario. For example, user opens web browser and types in URL of the web shop. It's kind of step 0 of the main flow, the triggers, right? And then main flow is a list of single line requirements or steps that are expected from other actors that you cannot set requirements towards, like user or web browser, that you expect as reaction to actions of your system. Step 1 could be that webshop shall detect not logged in user. Step 2, webshop shall display login window. And in this simple scenario, that would be probably all. Post conditions, the state, observable state of the system after the scenario is executed. User cannot use webshop without logging in. And then don't forget about exceptions that explain what can go wrong in each of the steps of the scenario and how system reacts to that. Here is more or less same thing in the form of a diagram. So I think it looks more appealing, right? So the general recommendation would be that perhaps it's better to use diagrams whenever you can than a text. On the right-hand side, you can see plant UML code that was used to generate this diagram. So maybe for programmers, that would be also something nice, that writing specification could look a bit like programming, right? OK, so you already know what is specification, how it can look like. What the requirement is not. Requirement is not implementation. Because no specific software design must be derived from the requirements, there can be multiple options how this can be implemented. Requirements tell what is required, not how to do this, leaving some room for the developer's creativity. Requirement is not a general story, information about the background and history of the function. Of course, it is useful, like a rationale in the single line requirement or a description in the user scenario to give some background, but it needs to be clearly separated from the requirements themselves, so that no requirement is missed in the esoteric description. Requirement is also not a test case. It must be verifiable, but single requirement could translate to multiple test cases. It's up to the test engineer to design a test plan based on the requirements. Let's see who are the customers of the specification teams. Who needs specification? First of all, product managers, project managers, business analysts. This role is called differently in different companies, but I mean here the people from the project who have direct contact with the customer, who are collecting the requirements from the customer. They need to be able to check up to a certain level of detail how the feature is going to work, if it's going to deliver what they have promised to the customer. Developers, they need to plan the implementation based on the requirements to be sure that they deliver what customer wanted. Testers, they need to verify if the developed feature fulfills the requirements. Customer documentation, so those guys who are writing the user manuals for the end user, they need an input to describe to the customer how the feature works. In Nokia, some of the customer documentation teams actually have access to the test environment. So they take specification as an input. They can execute the user scenario on their own and see how it works, and then reliably describe it to the end users in customer documentation. And at the end, specification teams themselves. Those are most frequent users of the specification. Specification teams need to have a database to assure that new features are not breaking any existing design, to be able to track dependencies between functionalities, and to be able to quickly find requirements and refer to them in the discussions. Let's think, what are the consequences of not investing in the specification of the system? Some may think that specification is some kind of burden, something that needs to be kept up to date. But if you don't have any specification, you can run into multiple troubles, actually. First of all, it's difficult to remember everything. So when you don't have specification, you can only rely on what people think that things should work like. It's difficult to estimate costs and schedules. You don't have a way to measure the size of the feature. There is a higher risk of omissions, misunderstandings, inconsistencies, causing the need of redesigning, recoding, and retesting, which costs and causes, of course, project delay. There is higher risk of spending time on work that doesn't serve the end user. There is also no translation layer between the standard and the project world. If you ever try to read 3GPP or ORAN standards, they are a huge amount of documents written in a way that is difficult to read, using very general terms that are universal for all the companies. And someone needs to actually go through this and translate it to the project terms. That's not the end. It's also difficult to transfer the project to new users, machines, or development teams. If you don't have specification, there is high probability that you will be wasting time for the same discussions over and over again because you don't have any ready agreement on the paper. And don't get me wrong, questioning the design is a good thing in principle, but going in circles, discussing same things over and over again, that's a waste. It's also difficult to let the experts leave the project. That's always difficult, but as a project leader, without specification, you are kind of kept hostage because all the most precious knowledge is only in the people's heads, not written down anywhere. It's also difficult to onboard newcomers to the project. Since the specification is updated with each new feature, it is usually up to date. So it's a great source of knowledge to onboard new people to the project. Are you scared enough now? Are those problems really serious and you are considering now starting writing specification for your project? If yes, then I have prepared a recipe in 5 simple steps how to prepare the background for writing specification. So where do you start? First, set the boundaries of the system under specification. Decide what will be specified. Here it's a totally random system, and just draw the system from your area and decide what parts of the system are in your control, meaning that your company is delivering that product, or you are ordering it from the subcontractor and you have agreed that you can set some requirements towards them. Clearly identify the external interfaces of your system in this blue rectangle. Define the interfaces towards neighboring systems. Define who are the users of your system. Step number 2, divide the system to functional, hardware, and software layers. Sounds scary, but it's actually, the procedure is very simple. Look at your system and think, what is your black box system called? Look at it from the perspective of the functionality, of the hardware, and of the software system. That biggest black box, or perhaps few black boxes, would be your layer number 1. Then try to open that box and see what smaller black boxes you have inside. That would be your layer number 2. And you repeat that process as long as you can. That would be the horizontal split. And vertical split would be within all those layers to functional domains, like you may have aspects related to the security of the system, aspects related to upgradability of your system, and those can be handled in parallel by different teams, perhaps. Why do you need those layers? In short, to translate the architecture of your system to practical feature development process in your company, to your organization. If system is complex, there can be many people in various roles involved in the feature development process. There would be people closer to the customer, like on the left-hand side of the picture, that are mainly interested in the externally visible design, how the end user will see that system, and they don't necessarily need to know all the details how it will be coded inside. On the other hand, you have experts that need to implement particular algorithm, and they need to know those details to be able to deliver their work. Don't try to specify everything at once. This division to layers, those all sizes of black boxes, are for you to realize how complex is your system and how many of those layers do you need and how will you translate it to stages of the feature development. Because it's technically not possible for everyone to know everything. The composition of the system to layers of abstraction is needed because people who are participating in the specification at a given stage needs to understand what is written there, right? So let's look from the perspective of the product manager. He needs, or customer documentation. They need to know how the feature will work on the very high level. And developers, of course, need to someone to translate this very high-level picture for them to more detailed design, to be aware what they need to deliver. More about it also in the step 4, but now step number 3, decide about common terminology to be used. It's a good idea to start from the standards. Call things in the same way as they are called in the standards. Create a glossary. Define the terminology, define how each of those black boxes is called, and use that terminology consistency across your project, both in customer documentation, in specification, and in internal software architecture design. People communicate better if they speak same language, right? Step number 4, decide how particular system layers discovered in step 2 translate to the feature development stages. Here's the V model depicting the feature development cycle. On the top, you can see layer 1, 2, so the biggest black boxes, and the smallest black boxes on the bottom. There is no universal recipe how to do this. It all depends on your project, of how many layers do you have. You need to look at your team and decide how many layers, how many sizes of black boxes fit into the one level of specification and one corresponding level of verification. It may be so, like on this example, that 3 highest levels translate to one specification level, but it can be also that one layer would translate to one specification, one verification layer. Okay. Going back to specification examples so that you understand this difference between the levels of specification. Here is this high-level specification level 1 example that I have already shown. Single line requirement: when a new web shop HTTP session is started by not logged in user, web shop shall display login option. How this requirement could be decomposed to a more detailed specification on the level 2. For instance, this way. When a new webshop HTTP session is started, a webshop backend, new actor, more detailed, not visible to the end user directly, shall detect if the user is not logged in. And requirement number 2, when a webshop backend detects not logged in user, webshop frontend, also new actor, shall display login banner. And login banner would be also something internal, defined in your glossary. That is not, the end user doesn't know that you call it this way, but for your project it could have some meaning, right? And step 5, maybe least important, but worth to mention, find the tools for specification storage. There are plenty of specification tools available on the market. The ones I have used are Magic Draw, IBM Doors, Sphinx. I don't want to comment any of them or compare, list pros and cons. There is one general lesson I have learned from using any specification tools. Tool needs to be easily accessible and browsable by people without any special training, without installing any special tools, going through hours of manuals. Otherwise, nobody will use it. In Nokia, it works best if you have some user interface in the web application that allows you to search some keywords and based on that find a piece of specification related to that keyword. So then, really, I have seen that even developers are looking into specification and using it. When you start writing specification, you can start even using a typing machine and store it in an analog way, like on the picture. You can use Microsoft Office, doesn't matter. But with time, when your specification grows, you may decide to use some tools that would allow you for using those features, like versioning system, parameterization. So instead of having 5 exactly similar requirements for different types of hardware or software release or element of the system, you could have just one, use some variable in the text of the requirement and have an attribute that is listing all the system elements to which this requirement applies. So then you have just one requirement that is specifying kind of many fragments of the system. Linking. So it's very useful when you read a requirement and it refers to another, that you can just click the link and it moves you there. And of course, search function. Those are useful features that documentation or specification tools offer. All right, what are then the characteristics of a good requirement? When you have went through those 5 preparation steps, you are ready to start writing specification, what should you pay attention to? Here is a set of those characteristics that are worth to consider. Those are just recommendations, so there is no guarantee that if you stick to those recommendations, your specification will be perfect. And also, if you don't fulfill any of them, it doesn't mean that your specification is useless. But this is based actually on the IEEE standard from 1998. Previous version was from 1993, so this standard is quite stable. So you can trust it more or less that it really is used in the industry. Let's see one by one what those characteristics mean. Unitary or atomic. Requirement unitary or atomic means that requirement addresses only one thing, doesn't contain conjunctions. This way, it's very simple. It can be easily implemented and verified. But of course, there is this disadvantage that if you try writing very atomic requirements, the amount of requirements will grow, and perhaps your database won't be readable, searchable by the human being. Next characteristic is correct. Correct means that requirement expresses what is needed. And how do you know it's correct? You need to go to the person who has requested the feature and check with that person. Review the requirement with that request originator to be sure that it expresses exactly what was needed. Unambiguous. It means that to the possible extent, the requirement has only one interpretation. When requirements are written in the natural language, it's difficult to have them unambiguous because the natural language is ambiguous itself, right? One hint is to use as simple language as possible. Then you increase the chance that the requirements will be understandable by the multinational community you are working in. Complete. For a single requirement, complete means that the requirement is answering all the questions. Who needs to do what, when, and why. So it has a complete structure. For a set of requirements, complete would mean that your set of requirements is covering all the functional and non-functional requirements, exceptions, glossary. Addresses everything that is needed. Consistent. Consistent characteristic of a requirement means that there are no contradictions between requirements on the same level or between different levels of requirements. Verifiable. Verifiable means that it can be verified, that it uses well-defined terms that can be measured or checked. Imagine trying to verify a requirement that is referring to following terms: never, always, too low, too high, user-friendly, works well, normally, minimize, maximize, etc. I don't know how I would verify that, so try to avoid them. When writing specification, think how it will be verified. It's also a good idea to invite test engineer to verify, to review your requirement and assure that it is verifiable. Modifiable. It means that requirement is generic in structure, it's easy to extend it, and it's easy to port it to new, for instance, new hardware platforms. One example of not modifiable requirement would be a requirement that contains a table that is pasted in the form of a picture. Then you need to redo the entire table in order to change any cell in that table or add any rows or columns. So try to using modifiable, extendable objects instead of screenshots pasted in the requirements. Traceable. Traceable means that the origin rationale of the requirement is known. For downstream requirements, it would mean that they have a reference to the upstream requirement from which they have been derived. Okay, so instinctively, when you start writing specification, you will start from functional requirements, but don't forget about non-functional ones. Non-functional requirements help to judge the quality of the system rather than how the system works. For example, you can have performance requirements. How long does it take for the system to perform certain operation, or the mass amount of operations, system capacity requirements, how many operations or users the system is able to serve, or how much hardware resources it requires to be deployed. System reliability, availability, resiliency. For example, what are the acceptable service breaks? It's typically very difficult to write non-functional requirements upfront before you have actual test results. Last question, is the specification costly? And my answer is no. It is actually quite cheap. When I have looked for the statistics in Nokia, in the project I'm working in, of the entire feature development effort spent this year, specification was like 10% of the entire effort. And remember that it is amortized by all the costs that you would need to pay for reworking your solutions if you have any omissions, misunderstandings, and so on. So I think it pays off. Let's summarize now. Specification is not a waste of paper if it's well thought, easily accessible, and follows good requirement characteristics. All of that makes it useful. Specification is not so costly and brings multiple benefits, or at least increases probability that you will fall into some serious troubles. Decreases the probability of falling into troubles. And also requirements engineering is an interesting and challenging career path that is frequently underestimated. On the technical universities, there are no courses typically about requirements engineering. On the universities where programmers are taught. So I thought it would be interesting to mention this topic on Code Dive. I didn't see it on any of the previous editions, so I took this opportunity to just bring it to you, and maybe it's something worth to consider as a career path. It is interesting because it's really creative. You need to constantly learn about new technologies. You need to have both technical and soft skills to be able to work with all the people involved in the feature development process, to build a circle around you, because at the end, the specification, the design of the features is not one-man job, it's a teamwork. In my team, I have experts from various backgrounds. There are people who previously were software developers, like I was, people with background from testing, from customer support, from product management. All those experiences give us a bit different point of view on the problems and help to design features best way we can. All right, so wherever you are on your career path, whether you are still studying and maybe already not feeling thrilled about coding for the rest of your life, then maybe it's a nice alternative for you to consider. Or maybe developer work is your true dream, but you still have many of years of work ahead, and maybe you will change your mind. That's all I have prepared for you. Thank you for listening. And now, time for your questions.
If you have any questions, raise your... Okay, yes, good, perfect.
Hello.
Hi.
Vladislav Bondar, Nokia. At the beginning, you described the different types of requirements, but actually there is no rule that in your project you should use all of them at once. Yes. And my question is, what requirements type are the most convenient and the most frequently used for the different groups of users, from the customers on the one side and for the development teams on the other? Thank you.
I think the most convenient way is diagrams. It depends on the complexity of your project. If the project is very simple, then it would be easier perhaps to write those single-line requirements, short requirements that would list all the functionalities that your system elements are required to fulfill. But if the system is complex, the best way to see how all those actors interact is using user scenario. And in my daily work, I work in the highest level specification. I use mostly user scenarios. Any other questions? If no, then I have a question for you. How many of you have specification in your project? Oh, wow. That's quite many. I'm surprised. Good job. Keep doing it. Thank you. Okay.
Okay, thank you, Natalia, once again. Thank you very much. We have a gift for you.
Thank you.
Of course.
Thank you very much. Thank you.
Okay. You can sit down if you want to, not a problem. Okay, and Natalia finished earlier, so right now we have 20 minutes until the next lecture. So take your break and see you here in 20 minutes. Thank you very much. Hello, once again after the break. We are in Wrocław in Kino Nowe Horyzonty for those who are watching us online. And right now we will have a speaker who's here for the 4th time. He's been working in many industries and he asked for a short introduction because we are running out of time. Viktor Kirilov.
Okay, so today we're going to present yet another solution to online identity, which is decentralized. And first, we're going to go over some of the problems with the current web. And the first thing is that it's host-centric, which means that everything happens on with IP, DNS, and unicast communication, which means that all of the links, the URLs which we have, many times they get broken, and either the content is no longer there, or it's a different content. And also the documents which we get from a URL, they're host certified, which means that we need to trust the host that whatever we get is what we were supposed to get. And even the designers of the internet by now agree that they shouldn't have used IP address both as a locator and as an identifier. And also, within 20 years, more than 98% of all of the URLs on the web are broken in one way or another. And effectively, we are experiencing a comprehensive breakdown in the chain of custody of facts in the web, and we're building our history on shifting sands. There's also a lot of centralization on the web. DNS, certificate authorities, Google and search, browsers, cloud providers, data centers, routing. We're also living in the surveillance capitalism right now, where personal data is the most valuable commodity, and trillion-dollar industries are built on top of it. Also, the algorithms which recommend to us content, they're black boxes to us, and they're the ones which determine what goes viral and what ideas surface and what propagates. And currently, the people who write the algorithmic feeds in our social media are perhaps maybe the most powerful people in the world. And for that, you should watch The Social Dilemma from 2 years ago, a documentary. Another problem is with social media and identity, that we think that we have our own social capital, but in reality, the Web 2 platforms, the current platforms, own our reputation and everything. And our identity is centralized and fragmented in just a few large players. And currently, we don't have much choice, because if we want to leave a social network, we're going to lose all of our connections, reputation. We cannot export it, and that's because the network effects of these platforms are too strong. And also, there's no accountability and transparency in how they moderate content or what their algorithms actually do. And there are many other problems. Another problem is the vertical integration of these big companies. And because there is no interoperability between them, that means that we have less innovation, and also that they have to re-implement many times the same things over and over again, because they can't reuse it, because they have to keep their data to themselves, and they can't share it easily. And that means that the effort to solve some of the problems is fractured, and it's done again and again and again in a few big in-house places. And also, they compete for the same set of talent to solve the same problems, instead of, if we could solve some of these problems only once, and all companies could use that. But we're not in that world now. And also, many platforms have APIs, like Twitter, and many ecosystems were built in the past, which were then killed when the platform decided that it's no longer advantageous for them to offer these APIs for third-party clients to develop on them. And also, there's a really hard barrier to entry for new startups, especially if you want to make a new social network. So now we're going to go over some of the building blocks which we're going to use in order to design our solution. And the first thing is the Merkle tree. I hope that you are familiar with hash functions and public key cryptography. So if we have 4 elements of data, and if we hash them individually, we're going to get 4 hashes. If we then combine these 4 hashes in pairs and hash the hashes in pairs, we're going to get 2 more hashes. And then if we hash those middle-level hashes of this tree again together, we're going to get a top hash. And now, if we change any of the 4 elements at the bottom, their hash will change, and that means that their hash of their hash will change, and that means that that change will trickle up to the tree. And that means that the root hash will no longer be the same. And so if we commit 4 elements with a specific root hash in this tree, and we can later reconstruct this tree for these 4 elements, and if the hash matches the root hash, we can be certain that it's the same 4 elements in the same order. The next thing we're going to discuss is a Merkle proof, which is basically a way to prove that something was included in a set. And again, we have a Merkle tree where 16 elements were hashed, and then those hashes were hashed together, and that way up to the top. But suppose somebody gave us just the green element. And he didn't want to give us the other 15 elements, but he wanted to us to know that this green element was included along 15 other elements in a set which was committed with a Merkle root. All we need to do is, if we have these 4 blue hashes, we can reconstruct the root hash if we have this green element, if we hash it, and then if we hash it with these blue hashes, we can reconstruct the root hash of the tree. And if that matches with the root hash, which we know is the real one, we know that this element was for certain included in this set, and we don't need the other elements in the set to check that. All we need is some other hashes. Next, what is a blockchain? Well, it's basically a hash-linked chain of blocks. And yeah, basically every block contains a hash of the previous block. And also every block contains a bunch of transactions, which are the changes in this new block. And what's the difference between a blockchain and a state? The blockchain is the list of transactions. It's the list of changes, the incremental patches, the diffs. But the thing which is limited there is the block space, how much we can fit inside of a block. And that's because of the distributed consensus between the machines in the internet. And the state is actually the current state of the ledger, which is who owns what. And it is materialized by applying all of the changes from all of the blocks to actually get the current state of the ledger of the world. So the blockchain is the diffs, the state is the actual current state of the current shared database, a state machine. And every blockchain has a state transition function, where it takes the old state, a diff, which is the next block full of n number of transactions, and it computes the new state, which is the new state of the shared database. And also, this state, which is the current representation of who owns what, it can be also Merkleized, and we can construct a Merkle tree out of it and a Merkle proof, and we can include that Merkle proof, Merkle root of that tree inside of the blocks, so that the blockchain does not contain the state, but you can construct the state with the blockchain, and also the blockchain, each block contains a Merkle root of the state, which would result if you construct it up to that point. Another thing we're going to discuss is what is content addressing and IPFS. Well, if we hash a file, we're going to get a content hash of that file. And the interplanetary file system is a content addressable peer-to-peer network, where we request the file by the content hash. We just submit a request in the peer-to-peer network, and we get the file later on. And there are no limits to the number of files or their size, but we can have some latency issues. Another thing to note about IPFS is that it is an unincentivized network. That means that just because something has an IPFS address does not mean that you'll be able to retrieve it. Nobody has to store it for you. And that is just like torrents. So here's a problem statement. We have reached the local maximum with the web. And how can we use Web3 beyond all the buzz to actually improve social media and the web? And I think that we should start with identity. And I think it is the foundation. And what is actually an identity? It's an identifier and nothing more. And we should follow the Unix philosophy to do just one thing very well. And everything else should be composed and layered on top of it. We shouldn't try to handle everything in this world. So no NFTs, no creator coins, no finance and whatever. And yes, everything else, like profiles, verification, KYC, privacy, all of that can be layered on top of identity. And we're going to combine existing building blocks in designing this system. First design goal will be web scale. So the web is huge. Within 1 minute, we generate literally hundreds of terabytes of data, or maybe even more. And it's literally enormous. And we should design it for billions of users and for unlimited data. Another design constraint should be Web2-like user experience. What does that mean? It means that we shouldn't ask people to actually deal with public and private keys and transactions and interactions. And we also shouldn't expect people to host their own software at home to run it. Like even the most diehard crypto natives, they want to actually use third-party services because it's much easier. And the last thing is that the URIs which identify content, it should be human readable. It should be human readable. It shouldn't be full of hashes or just numbers. There should be names inside of it. And currently, every Web3 solution only has hashes. The third goal should be decentralization. Like, you should be sovereign when it comes to your identity. If you have a key pair, you should be able to own it completely. And the other thing is credible neutrality. So anyone should be able to create an account, create a service, or broadcast through the network. But we should distinguish between speech and reach. Just because you can speak and have your content addressed does not mean that anybody will be processing it and displaying it to others. So content moderation is just another layer on top of this. And also, anybody should be able to run their own software at home, but that will be at a disadvantage because they won't be able to aggregate all of the activity on the web, right? And also, decentralization should be the base layer, and you cannot build something decentralized on top of something centralized. It has to be decentralized, the base layer. And the fourth goal should be simplicity. Like, it should be really clear why and how much it can scale. There shouldn't be, it should be clear. And it should be also really clear what are the guarantees for data availability, for the economics of the system, like when would it break, and also how much time it takes for a transaction to be final. And if we could construct a global singleton that manages all of this scale, that would be the easiest to work with. And the key is to design that singleton. And that would be the easiest mental model for everyone if there was only one blockchain and not a landscape of different chains and bridges between them to actually solve this problem. If we can solve it with a singleton, that would be great. So the first distinction which we're going to make is on-chain versus off-chain. And on-chain, we're going to put the absolute bare minimum, which means account identifiers, which in our case are not going to be even hashes of the public keys. It will be just an auto-incrementable integer. Another thing which we're going to put on chain is the public key ownership. And that's actually optional, because users in our system do not need public keys, but they can, at any point in time, bind keys to their accounts. And also name ownership, like who owns which names. And that, again, is optional. You don't need to own a name in this system, but you should be able to. And also, some of the authorization actions are on-chain, but most will be off-chain, and we'll discuss that later. And the last big thing which will go on-chain is the Merkle routes for off-chain data. And what is off-chain data? Off-chain data is all other events, documents, actions, content, whatever, all of that. And applications where users generate it, applications are going to generate it in big batches, and they're going to submit this content to the chain in a batch. But they're not going to submit the actual data to the chain. They're actually going to construct a Merkle route with all of these events for the latest batch, and they're going to submit only the Merkle route, the hash of the Merkle tree, the top hash, to the chain, and that's called a commitment for the entire blob of data. That's also called anchoring. You anchor the blob of data. And there are going to be 3 types of accounts. Like the first is normal users, the second is identity managers, and they're going to handle authentication and authorization with applications for users. They're also, so think of this like single sign-on, login with Google. You have your identity manager, and you're going to log into different services, applications, with your IDM. It's going to also handle direct messages for you, and maybe it's going to archive your activity. And we can think of IDMs as custodial because you don't need a key by default, and they're sort of going to own your account. But later, we're going to see why that's not such a big deal. And actually, you can also host your own identity manager at home. And the third player is going to be applications, which are going to be used for browsing and publishing media. And actually, all of these 3 players are going to have on-chain IDs, and even a single entity can play all 3 roles. But it's useful to have them separate as a mental model to think about them and the different categories which they'll be playing, the different roles. So when users want to view media through applications, they need to authenticate off-chain using their IDM or keys, which means that they can either sign a message or their identity manager can create an access token to the application, but that doesn't have to happen on-chain. That can be just an event in a big blob, or it doesn't even have to be anchored to the chain. Another thing which users are going to be doing is they're going to be posting content through applications. So not just reading and logging in, but also posting. And for that, they're going to either authorize the application to post on their behalf without having to have their keys next to them and sign every action explicitly. They might just authorize the app to post on their behalf with no signatures. And that can happen either on-chain with an identity manager, as we will later going to see. And such on-chain authorizations, they're batched together by the identity manager, and they contain only one signature by the IDM. So you don't have to explicitly, as a user, sign anything. The IDM signs a big bunch of authorizations for maybe 1,000 of its customers. Or another way is off-chain authorization, which is, again, with an access token, with something like OpenID or ZeroAuth or something like that. Or if users don't want to authorize an application to post on their behalf, they can explicitly sign content with their keys if they have keys. But that's very cumbersome. And the last thing is that applications, they're going to aggregate content which was generated by all of their users, and they're going to submit it in bulk, as we talked in the previous slide. So again, the content, all of the events, comments, likes, that's off-chain in big batches of data. And only when you construct the Merkle tree and the Merkle root of that tree, only that Merkle root goes on-chain to commit, to anchor all of that data. And so the blockchain will be hidden in the background for users. They won't have to touch it by default. And all of the costs will be covered by IDMs and applications. So what are off-chain messages? Well, that's basically any event, action, data, document, content, whatever a user does with his interactions, that's an off-chain message. And there will be a taxonomy of message types. Like there will be in a hierarchy, and there will be a few base types, and we'll be able to inherit those and create new types. And we should have a fallback presentation for new types. Why? Because initially, every new type is not supported by a bunch of applications. Maybe only one application supports a new message type. But we should be able to introduce new message types in our ecosystem. And if there was a fallback presentation, we will be able to gradually evolve the system and introduce new messages without breaking everything. So suppose we have a prediction message, which is, in this case, a JSON object with a few attributes in this case. And if we had a fallback rendering template which substituted the different attributes in different places in a string, suppose when somebody creates such a message and some other application does not yet support how to visualize it properly with different colors and buttons and whatever, it can just stringify it and show it as a string message. And that still shows that someone else on some other application created this message and he broadcasted this to the world. And if somebody is following him, he should be able to see this activity, even though it's a new message type. So everything is a message. Like every time you follow someone or you become a friend with someone, or all of your account preferences, or all of your content which you generate, that's a message. Also attestations, verifiable credentials, all of that. And you actually can also have privacy and even group discussions, closed groups with messages, because these messages, they don't have to be unencrypted in these big blobs of data. They can be encrypted in such a way that only a few entities can decrypt them and show them only to specific sets of people. And also, these messages, they don't have to be accessible by the public web. Just because you build a Merkle tree out of a big blob and you post the Merkle root on chain does not mean that that blob of data is accessible. So you can actually use this for intranet for companies. Like you can have internal documents which are using this global identity layer, it's using this global addressing layer and this Merkle root scheme, which we're going to later see how it's used. But still, that doesn't mean that anyone else in the public web will be able to download your data. And so we can actually rebuild any primitive and service from Web 2 with just messages. So what does the content blob actually look like? So first, applications, what do? They collect a bunch of messages from their different users. After that, they group them by user. And in this case, we see that the orange user has 3 messages, 1 post, 1 like, and 1 comment. We also get indexes for the individual elements within each group, starting from 0. And then, when an application decides it's time to commit the next blob of data, it constructs this big blob with all of these event groups with the activity of all of the users which actually did something. And it also creates an offset table, which we can use in order to index within this blob of data. Then it constructs a Merkle tree with all of these events individually hashed, and we construct this Merkle root. And then the only thing which the application posts on chain is the Merkle root definitely, and maybe the IPFS hash of the blob so others can download it, but that's optional. So what is a nonce? Nonce is, in our case, going to be an on-chain number tied to every account. So when an account, which will be most usually an application, publishes a batch of data with a Merkle root, their nonce is going to be incremented. And the blockchain is going to save the nonce for this account, how it maps to block height, which means in which block did this application submit its third batch of data. And so whenever an application is constructing a batch of data with a bunch of messages, which are comments, likes, whatever, all of them, they will be assigned to the next nonce of the application when this blob is actually published. And this is used so that we can translate the pair of an application ID and a nonce to a block height. And then we can use the block height to actually get the block and actually get the Merkle root to verify all of the content. So how do we address specific elements within a big blob of data which some application has constructed? Well, we have the application ID and the nonce, the first two integers. With them, we can get the block height, from which we can get the block, from which we can get the Merkle root for the entire blob of data. And we can then verify the integrity with the hashes of all of the elements. And then we can use the offset table once we have fetched the blob, and we can actually drill inside of the blob with it, and we can see where is the activity for user 644. And then we can also even ask for the third element, in this case index 2, of that user. So we can actually individually address any element without any limits to how big these elements are or how many they are, with just 4 integers, not some hash. And this is what it's going to look like. Like, we have a blockchain where the only thing which goes on in the actual blockchain are these commitments, these anchors made by applications for a lot of off-chain data, which is in big blobs. And in these blobs, there are going to be all kinds of elements, and they can evolve, and they can be new kinds of elements, whatever. And they can refer to each other with these URIs, with just 4 integers. Any element can refer to any other element which was already created or is within the current blob of data. So we have effectively constructed a global virtual address space. And accounts which are owned by applications, for example, they can signal on-chain some way to be contacted directly. Like, this is my REST or RPC API endpoint. And so we can retrieve data for URI in many different ways. We can either fetch the entire blob from which it was actually committed by tracing which was the block height, and we can request that. We can request the Merkle root and the hash of the blob, and IPFS hash, and then fetch it. Or we can ask the application, because we know what was the application used, because it's part of the URI. It's the first integer. Or we can ask the user or their identity manager, which we can see on-chain, because we also have the user ID inside of the URI of this specific element. Or we can actually ask some archival service for this URI, or we can even use a peer-to-peer network, which is URI-focused. And then we can use a Merkle proof to check the authenticity if whatever we got is actually indeed corresponding to this URI, if the hashes match. So this is basically an infinite virtual address space. And many other protocols, they deal with storage and retrievability of data. But in our case, we only address data. We don't deal with how it's stored and how it's retrieved. We just allow others to do that. And they can even change how that's happening. But the key is that the addressing of the content is permanent. So let's see what our blockchain state looks like. So not the different blocks, but actually the materialized state, which shows who owns what. So first of all, we can see that the different elements in this state, we have constructed a Merkle tree out of that. We have hashed those elements individually, and we have constructed a Merkle root. And now we see that there are name states and their account states. We have 2 account states here. And the one on the right, we can see it's identity 7, and it has had different public keys which were bound to it at different block ranges. And it also has a nonce mapping. So for nonce 1, it was block 5. For nonce 2, it was block 6. So this is probably an application, because otherwise it wouldn't need nonce, because it has probably anchored off-chain content. This is most likely an application. The other account, it doesn't have public keys, and it only has different block ranges when it had authorized a different account to do actions on its behalf. OK, sorry. But now let's look at the names. One of them is Joe, and we can just see that Joe was owned by different accounts within different block ranges. But the other account name state is Twitter, and we don't see only the owners, but we also see another nonce. But this nonce is a different kind of nonce. This nonce is a name nonce, and it doesn't map to a block number. It maps to an account ID with an account nonce. And now, why is that useful? Because whenever an application which owns a name commits on-chain a bunch of off-chain data in a blob, the name nonce is also going to be incremented, and it's going to be mapped to the account ID and account nonce at that time. So suppose we have this URI, which is no longer with 4 integers, but actually with 2 names and 2 integers. We can actually ask the blockchain to translate the name and the name nonce to an account ID and an account nonce. Then we can ask the blockchain to translate this account ID and account nonce to a block height. We can then ask the blockchain to tell us who owned Johnny at that block height, at that specific point in time in the blockchain. And then now we have the canonical form. So we have effectively translated a human-readable URI to a canonical one with just 4 integers, and still the same thing. And even if the ownership of these names changes in the future, our original URI at the point of publication of that content is still the same. Not still the same, but it can still be translated to the canonical URI. So links are not going to be broken as long as someone still holds the data somewhere. And this is something which no other system in the world can do. And so instead of having caches full of, URIs full of caches, we can have URIs full of names, and they can be permanent and stable. So let's see what can users do. They can have a public key, and a private key, of course, and they can sign actions explicitly, and they can be completely self-sovereign. But that's very bad user experience, and it's very stressful and risky. They can also have a key, but they could have authorized an identity manager and applications to post on their behalf without requiring signatures, and that's a lot better UX. But they still retain the ultimate control, because if any application post something on their behalf which wasn't actually posted by them, they can actually revoke the access with the key and even retroactively revoke the access. And also some users might choose not to have a key at all, and they can be created on-chain as an account by an identity manager and be effectively owned by it. But at any point in time, they can graduate to a fully fledged citizen in this ecosystem who has a key and bind it. And so also users will not be thinking about the blockchain transaction costs, and they won't have to think about wallets by default. So here what do we have? We have 3 users, 2 applications, and 1 identity manager. And on the top we have the blockchain and IPFS for the big blobs of data. And so the user on the right, he has a key, and he's signing explicitly his actions when he's using Reddit. And he's also from time to time submitting an on-chain transaction, because he can. But the other ones, the other 2 accounts, one of them has a key, but the other does not. But they both have authorized an identity manager, and they have then used that identity manager to authorize applications to post on their behalf. So whenever they're interacting with Twitter or Reddit, they don't actually have to have their private key loaded in their phone to sign messages. And we see that only Twitter and Reddit, they talk directly to the blockchain and to IPFS. And whenever one of them constructs a big enough blob of data with user activity, they push it to IPFS, and they also upload the Merkle root for all of the elements on the blockchain. So the blockchain is used mostly by applications and identity managers. And what mostly goes on it is Merkle roots, maybe IPFS hashes if we want that data to be retrievable. And identity managers, they just post compressed pairs of integers of who authorized who, and revocations of authorizations, and maybe key pair changes. And so the bulk of the activity on the chain happens by services, not by users. So it's not about being trustless, it's about better trust. We don't want to have to deal with keys every day. I mean, we need familiar user experience, what we actually currently have with the current systems. And this is possible because creation is different from finance. And we can have different trade-offs for a blockchain which is organized around identity and creation. And that means that our off-chain data, it does not need to be available, and we don't need to think about the storage and retrievability of that data in our protocol. We just need to address it. And the retrievability guarantees, they can be on a best effort basis. If an application does not actually make data available, but it should have, it's just a bad application and nobody has lost money. And the other thing is that custodial, meaning that you have authorized someone to post on your behalf, is okay, because again, there is nothing to steal. And the worst thing that can go wrong is that some application posts something on your behalf, but you didn't authorize it. But guess what? That's currently possible right now as well. Like Facebook can post on behalf of a president without them actually doing it. So it's literally the same situation, but a little bit better. So we can actually have self-authenticating documents. So when we fetch a document for a URI with the 4 integers, we can first check that this data was actually really corresponds to this URI, and it was actually included in the block with the Merkle proof. And we can also check if it was indeed created by the user. How? So either the data was explicitly signed by the key of the user, in which case we can ask the blockchain did this user really own this public key at that point in time? And because the state of the blockchain is in a Merkle tree, we can actually construct a Merkle proof for did this account actually own this public key at this point in time. So we can not just check that if this data was part of a blob, but we can actually check really if it was signed by that user at that time. And if he actually could sign it with this public key, private key. Or if the data is not explicitly signed, but it was the application was authorized to post on behalf of the user, we can again ask the blockchain state for a Merkle proof for was this application authorized at that point in time to post on behalf of this user. So again, we can check even that. Or if it's not on-chain authorization, it's off-chain with an authorization token. Again, it's going to be embedded in the message, and we're going to be able to cryptographically check it again. And so even if nobody hosts a specific document anymore, if we have cached it locally with the proofs, we can later resurface that document and prove the authenticity of it, even if the application and the user are long gone. So all we're doing is actually ordering integers throughout time on the blockchain. That's the biggest use case for it. And some throughput, some numbers. Suppose we target 100 kilobytes per second of blockchain growth, which is actually very easily achievable with modern technology around Ethereum. Like, it's not going to be Ethereum itself. It's going to be a technology around Ethereum, like a rollup, a scalability solution. And with 100 kilobytes per second, we can support 1,000 applications which anchor a big terabyte blob every 10 seconds. And we can also support 6,000 authorizations per second on-chain, which happen by identity managers, but which maps to around 0.6 authorizations per person if we were 1 billion people per day. But we can actually have unlimited off-chain authorization with access tokens. So we don't have a limit for authorization. This is only if we're using on-chain authorization, which we don't need to use, actually. And also, this is just really naive numbers without any optimizations. And also, we can actually go way beyond 100 kilobytes per second. So we have effectively built a time-stamping machine, a cryptographic sequencer of events, where every authorization event and key and name change is ordered in time. And also, on-chain and off-chain data is batched for efficiency, on-chain by identity managers and off-chain by applications in the big blobs of data. And so we can handle unlimited amounts of off-chain data, literally unlimited. And we can also we have the capacity for billions of identities on-chain. And the URIs, they're permanent, even those with names. And when are names useful? When they're part of a URI, which identifies a resource. Like, who cares if you own a name if the content which you generate is not tied to that name? Like, it's much more useful if it's part of a URI. And also, we can address within documents, because these URIs, they're stable. And if there's a new version of the document, it will have a new URI, which links to the previous one. But again, the old version, if we decide to address a specific paragraph of a post, or maybe some character range or audio range, again, that's going to be permanent. That's going to be stable within that version of the document. And this system can displace actually DNS and certificate authorities globally, because it's a confluence of multiple interrelated things. And it has very strong synergy and network effects. Because if we're just trying to solve names on the blockchain, like Namecoin or Handshake or anything like that, that's clearly not enough. We need multiple interrelated things together. So what we're doing is we are linking data to identity at scale with one chain, which links them, sorts them, proves them, and binds them forever. So what's the difference between a Twitter and a Reddit post? Well, they're both comments in a tree structure. Reddit expands the tree by default, or at least to some degree. Twitter only shows one level of comments. And a Reddit post is always a part of a subreddit. So Twitter is account-focused, Reddit is community-focused. But why don't we merge their state? They don't need to be separate states, and we don't need to have separate identities on these two platforms. And we can have shared reputation between them. And we can just use different UIs for viewing the same set of data. And so whenever I post something on Reddit, there should be something like a Twitter-like feed where people who follow me see my activity on Reddit. If they want to, they should be able to actually opt out of such activity. And same goes for YouTube. Whenever somebody posts a comment on YouTube, if people follow them on another platform, there's no way to know about that new comment. And that shouldn't be the case. That's only because the current status quo promotes monopolistic platforms which silo their data, and there is no interoperability between them. And so whenever identities become portable, that's when backends, applications, they become liquid, and we can actually move from one application to another much easily. And so this is what it means to be data-centric. So the focus is going to be on the data, but the applications, they're ephemeral. They're going to come and go. They're just different ways to view the data and interact with it. But again, the focus is on the data. It's going to be shared by all, because identity is shared by all. And how are applications and infrastructure going to work in this brave new world? So in this case, we have two infrastructure companies. So you can think of them like AWS. Their job is to ingest and store all the data, a lot of heavy lifting. They can filter it by some criteria. The criteria might be different. They can create algorithms and indexes and maintain those. And then what can applications do? They can choose an infrastructure provider, so they don't have to re-implement all of that themselves. And they can even migrate to another one if they want to. They can choose which indexes and what filtration to use for what to show to their users. And they can even let users choose their own algorithms and filters. Like, we can have a lot more choice, and the applications can give us what's available on the infrastructure below. And these applications, like Twitter and Reddit, which if they were implemented in this brave new world, they would be paying for the indexes they're using to the infrastructure company. So infrastructure focuses on the heavy lifting, on extreme optimization, and the applications, they can only they can focus on actual good user experience and only on what they actually need, which is the UI, or maybe ANT moderation, or they can even use different moderation filters from infrastructure, and they can just pay as they go. If you create a new interface and initially it doesn't have any traffic, and you don't have to pay because you're not making any API calls, but the moment you get a lot of users, you're just gonna start having a lot more API calls and pay for your usage. And you can serve ads. Again, why not? I mean, we're not going to have a world without ads, never, unfortunately. Or they can also charge for users. But currently, Facebook is always ad-free. I'm not sure if they have a subscription model. But in this brave new world, anybody will be able to create a new interface, a new application with a different business model. And they will be able to do it because they don't have to bootstrap their own network effect. So, a lot more interoperability, no more silos of data. And just like a compounding interest is really important to finance, the same is true for software. We need composability and accessibility and interoperability for data. And in this brave new world, anything can become a new data stream. Like anytime an account or a word or a URI gets referenced in the public content. And we can also have advanced filtering, and we can transform and join streams however we like, as long as somebody pays for the costs of processing of the data. And anybody should be able to create a new algorithm and a new index for the public data. But currently, you don't have access to Twitter or Facebook's data. You just don't. And when you create a new algorithm or a new index, you can pay a company, an infrastructure company, to what happened? Did it just happen? Yep. OK, what do I need to do? OK. And so users, I mean, people who create new indexes, they can pay infrastructure companies to maintain those indexes, and they can even charge applications to use their indexes if they're useful for anyone. And we'll be able to make any type of query which we want. And also, by linking data to identity without keys at scale, we can unbundle a lot of monopolies in decentralized media. We can have a lot more competition, lower barriers to entry, more startups, better search engines, or at least more competition, and a lot more choice for users, because now you will be able to actually leave a social network, but actually take all of your social graph and your identity with you to another different interface, because now applications are going to be just thin layers to present data, and the network effect is going to be shared. And we're going to be able to have composable media, when if you have a new idea, you can literally pick off-the-shelf solutions and code the literally minimal amount of work which you need to do to have something new. We're going to have a lot of redundancy and resilience because of horizontal scaling, because this addressing scheme is so it allows for a lot of topological flexibility. You can change where it's stored and how it's stored, but it's still addressed the same way. And so there are two ways to make money in this world. You either bundle or you unbundle. And in this case, we have unbundled the media stack into different layers, and we're allowing for markets to develop the best solutions possible for different layers of this media stack. And this is something which no company can do by themselves. This is something which only an open ecosystem can do. And Aristotle once said that the whole is greater than the sum of its parts, allegedly. So we can give birth to History 2.0, the ledger of record, where links will no longer be rotting because some host is no longer serving the exact same thing, or they have changed their resource paths because of some reason. And also the documents which we get from a URI, they're going to be self-authenticating because we can actually get the Merkle proofs and prove everything about them and link them to identity. And we can think about this as the global Git, where we'll be able to duplicate all kinds of documents, we'll be able to track all of the changes to documents, and we'll be able to view the different versions of a document or a page or a New York Post or whatever. And we'll be able to rebuild new systems of trust and reputation systems on top of this. And we can finally have argument from cryptography instead of from authority. And there are many other possibilities, like being able to see all of the public activity of someone, no matter from which application or what type of activity. And we'll be able to filter that multidimensionally by including or excluding based on the user or the application, the content type, the tag or keyword or whatever. Currently, you either follow or you unfollow, and that's it. We can have universal bookmarks because currently now these URIs will be permanent and stable. And imagine what kind of knowledge management tools we'll be able to build on top of this new web of permanent URIs. We'll be able to tune our notification settings because notifications are just alarm clocks which someone else is setting on us. Like, we should have control on when we receive the notification settings, but the current platforms, they don't have the incentive to give you those tools to limit your attention and time which you have spent on the platforms. But now we would be able to have new tools which let you do that. And we'll be able to fork communities and moderation filters and UIs if we're not happy with something. We didn't cover a lot of things, and there are a lot. And I want to leave you with one quote: "The medium is the message." Marshall McLuhan, who was a media theorist, once proposed that we should be studying the communication medium itself and not the messages which is carrying. So in this case, we need to take a look how we're, how the current social media platforms are constructed and how they operate. And also, we can think of AGI as artificial global intelligence, where every follow is a synapse in the global metabrain. And recently, Elon Musk said that you can think of Twitter as a collective cybernetic superintelligence, where a lot of billions of interactions are happening per day. And obviously, this is a single company, and it's not optimized for very much for truth or for productive conversation. And that's because it's a company which is trying to make revenue at the end of the day, and nobody has access to their data besides them. And also, the complexity nowadays is extreme in the world. And I think we need to upgrade the complexity of our sense-making to actually match the complexity of the world. And I think that the host-centric model must go, that we're currently in an asymmetric relationship with today's platforms. They have siloed our data, and we're their captives. And we've been given a one-size-fits-all algorithmic feed, which is our information diet for many people. And that's solely optimizing for engagement and time spent, not time well spent. And I think that, we shouldn't settle with what we currently have. And we should be able to surface any kind of signal, and anybody should be able to construct a new algorithm or a new index and let others use it if it's useful. And so what is the metaverse? Well, here's some quotes which we won't have time to read, but I think that the metaverse is going to be built in layers, and the bottom layer is identity. And I think that you should be able to have your activity in one social media linked to your identity, then you should be able to go through another application and have that linked to your identity as well. If you choose, you can actually have multiple identities. And then if you jump to some 3D world by some specific company, again, that should happen with your same identity. Like, the current blockchains cannot handle what they're currently talking about the metaverse. And I think that we need to build it in layers. And we don't need to add finance and NFTs to everything which we see. And so this is what the internet looked like in 2005. And this is basically the different internet protocol ranges and the routing paths, and they're color-coded depending on the region of the world which they're in, the different continents. And everything on the internet happens host to host. And the internet is the largest engineering project the Earth has ever seen. We're just getting started. And I think that it's time for us to add identity to the OSI model of the internet, because the internet is constructed in layers. And if we add a new meta layer of identity and content addressing, we can literally reshape how the big companies function. And I think that identity, the cool thing about it is that it needs to be solved only once. And if we can actually solve it once in the most perfect way, and there is no better set of trade-offs to solve it, then we can rebuild everything else on top of it. And that's the cool thing. Only once. And that's it.
Do you have any questions to Viktor? Please raise your hand if yes. Okay, there are 2 questions, and we have time only for 2 questions. Thank you.
Yes, so I have one question. What is the thing that can convince big companies like Facebook or Twitter to start using your project, start using the decentralized identity project, if they lose control over this part of their application? So this is not good for them. It's good for us, but not for them.
Yes. So none of the big companies would adopt this, at least initially, because it's literally a threat to their business model. But the thing is that if it's obvious enough that this is the right way, and if it's obvious enough for a bunch of entrepreneurs that there's a lot more low-hanging fruit in this ecosystem, if it's a new grassland for them, and if composability between new services can give a lot more value to users, and if that's obvious to people, they're going to want to build on top of this and not on the other platforms. And yes, this system will not be adopted by the big platforms. It's intended to kill all of them. And but the thing is that no single company can give you what this ecosystem could give you, because this is infinite composability and interoperability between platforms. And if it's explained the best possible way that this is indeed the best set of trade-offs, and it's the most realistic way to actually add identity to the internet, and if enough people believe it, I don't know. Like, whenever Ethereum was first built, nobody had any idea what the applications on top of it would be. And there's this saying that if you build it, they will come. And many venture capitalists mock that, because obviously it's not guaranteed that anybody will come if you just build a solution. But sometimes, if the solution is good enough and it enables a lot more innovation on top of it, and if it's communicated right that it is actually the right design, actually people come, even if you don't have a specific strategy. No, you need a strategy, but it's possible.
Okay.
Any other questions?
Yes, I have a question. What about GDPR and law to be forgotten?
Yes, that's one of the things which we didn't talk about. Yes, well, some things will be different. Like currently in this ecosystem, if you delete a post, you will have created a new message, and that message should be processed by all of the infrastructure companies, and they should remove that element, and they should stop serving it to others. But still, anybody will be able to cache it and save it locally. And it will be a little bit different for GDPR. There might be some bad actors which keep data which should have been deleted. But yeah, that's true even today. And even if we cannot cryptographically save things today, we can still screenshot them and post them again and again and harass people. Like online harassment, for example, it's been here forever, and it's probably going to keep happening. And this solution does not make it any much easier. It's practically the same, almost the same.
Okay, thank you. And one little question I have, because you have told that we can link a newer version to old one, but can we link old one to newer?
No. So in order to know that there is a new version, you have to have heard and processed the broadcasted event for the update. But so whenever you're using an application, and that application is aggregating a bunch of messages and it's posting them and anchoring them on the blockchain, that application can then signal to all of the users affected in that, who are participating in that blob, and that application can notify the identity managers of those applications to save this data. And then whenever you're using, whenever you're viewing a specific element, a text post, you can ask the identity manager of the user who created that thing has there been a newer version? So if identity managers keep track of all of the new events for their users from any application, they will be able to tell you, has there been an update to something?
Okay. Thank you, Victor, once again. We have a small gift for you.
Okay. Thank you.
Okay. Thank you all for your presence here. We have 10 minutes for the next lecture, the last one today. So please take your break for 10 minutes and go to whenever which room you want to go. Thank you very much. Okay, hello for the last time today in Kino Nowe Horyzonty on the 9th Nokia Code Dive edition. Please mute your phones because we will have our last presentation and we don't want any interruptions. And our last but not least speaker is Marta Rogowska. Marta has been an employee in Nokia for last 5 years, but she's also experienced in academic research. In her presentation, she will be able not only to discuss the research grant implemented at Nokia, but also she will be able to compare applying for fundings in the company at the university. Marta Rogowska, good luck.
Thanks for the introduction. So thank you for coming to my presentation. The title is Innovative Solution in the 5G Standalone Network. It's quite general, I think, but it is related to the research project that we develop in 5G team. It was said a moment ago that I've been working at Nokia since 2017, and during this time I had a pleasure to participating in creation of a grant proposal for 5G standalone network research project. And this application was accepted by National Center for Research and Development. It was some time ago, so today I can present to you the final result of this project and also all difficulties we encountered during this work, all works and something like that. So we can move to the next slide. So today I will focus on 3 major aspects. First of all, I will describe our project, our goals, assumptions, and something like that. I will tell you who developed this project, where it was, and something like that. After that, I will say a few things about innovations in this project, in our work, and after that, I will present results. But I think that's not all, because before working at Nokia, I gained some, let's say, scientific experience at Wrocław University of Science and Technology, and now I think I can present to you the difference between between work based on research project at the company and at the academy, and it may be interesting to you also. So let's start from the first item of the agenda. A few words about the research project. So at the beginning, we create a small team, which called R&D key personnel. It was me, another one specifier from the 5G team, one 3GPP delegate from our company, and also one line manager, which was project manager in this proposal. So I think that here we have the first difference between the academy and the company, because in the company we hired people to writing a proposal. At the academy it's not possible. So, but I think that it sounds better when it is actually, because we still, of course, we got from the company Ernst & Young a lot of tips to writing a proposal, a lot of advice, a lot of advice to what we should avoid in our proposal and something like that. But still we had to come up with the goals, the assumption of our project. We still have to provide technical content for the application, and at the end we still had to correct the draft of the application. So it's not a big difference, like it seems. Yeah. Oh, sorry. It's a tricky thing. Okay, so after creating a proposal, we got the acceptance from the National Center for Research and Development, and we received funds for the work. But how you can see here, we need a lot of engineers to implementing our goals, our assumption, and it was more than 200 engineers in different specialization. Most of them it was developers, but also specifiers and testers. And here you can see the official title of our project. I know it's long and really complicated, but it has some reason, because it increases our chance to get the foundation. So it's official one, but our daily title for the project is like the title of my presentation. And here you can see also the dates. The first dates refers to the implementation process where the engineers were working on our feature, our implementation, and after that we have the implementation of the project results. And now we are at this stage. So today I have the opportunity, but also I have to present our results in the conference, for example, on other events. Yeah, I think that's all here. So the main goals of this project are, I think that you can know these goals, because it refers to the 5G technology. And the first one was that the final effect will be to check the effectiveness of the 5G standalone system, but in less popular bands. Yeah, we plan that it will be for 400 megahertz frequencies and also 28 gigahertz. The second one is to minimize delays in the data transmission, and we would like to achieve about 1 millisecond. And the third is greater reliability, because we plan to implement the functionality of high availability for our 5G standalone system. And also the last one, it is the functionality which is quite new in 5G technology. It's new state, RRC inactive. So it was the last point for our assumption. And yeah, the issue is to be developed under the project include the following things, because we need to do some industrial research in the field, and also we work not only in software area but also in hardware area. I didn't mention it earlier, but we have small cooperation with 5G small cells team from the Krakow in Nokia, and we also prepare control layer for connection handling, especially in 5G standalone as a software, and also develop the other functionalities which was necessary to achieve our goals. As I mentioned before, we have one 3GPP delegate, and we it was a good thing for us because we can actively participate in 3GPP meetings, and despite the slowdown caused by COVID pandemic, we achieve our goals, and we attended on, I think, nine meetings, 3GPP meetings, and we could include our work there. It refers to improving mobility for New Radio SA. It was related to the handover functionality and something like that. But before saying a few things about innovation of our project, I would like to briefly introduce the overview of 5G standalone and non-standalone network. As you probably know, if we talk about the next generation of telecommunication networks, it is developed in an iterative manner. So in next generation, we have new functionality, new features for these mobile networks. So for the 5G, we have unlimited data capacity, but we start from the analog communication. So it's a quite big history for that. Here you can see the requirements and use case for the 5G standalone technology. And you can see here that our goals are similar to these requirements and this use case. We didn't discover these things. We only analyzed how we should implement this in our system. So it was our innovation, our work, not the discovery of these features, but how we should implement it in our system, 5G system. I also put here some general overview of our architecture, because we talk about standalone network, 5G standalone. So it's only based on the 5G infrastructure. So we have only 5G core. We have G node B, 5G node B, which is some logistic representation of the base station. And we have also typical for 5G interfaces like XN, F1, NG, and something like that. You can also here see the mapping, some kind of mapping between the physical parts of the system and logical parts like G node B. G node B is divided into two parts, DU and CU. And G node BCU is mapping to radio admission control protocol, and DU is more related to the physical entity like radio unit or radio access unit. This approach brought us some benefits. So it was supporting network scaling, improving the flexibility of the network architecture, and also, of course, cost reduction. And it is a really important benefit for us. Also, we have simplification of the core network, ensuring easy network segmentation. It is related to the network slicing functionality, but this functionality wasn't included in our research project because we only could include this functionality, which was completely developed and implemented in Wrocław. We couldn't use any features that was our implemented on China or something like that, because our funds came from the Polish Center of for the Research and Development. So it was a tricky thing in this case. So now the operators can choose, of course, in what deployments they're introducing 5G. They can choose 5G standalone, as I said, with all functions and features of for this technology, and completely related on the 5G infrastructure, or can choose also 5G non-standalone, where we have some, let's say, transition model based on the 4G network infrastructure. So here you can see some comparison between these deployment options. We have 3 options here for 4G, so LTE technology, and for a mixed option for non-standalone 5G, and for SA, so standalone option of 5G network. Okay, I think the first quite big functionality which we should implement in our team in this project was connection handling. So we concerned on totally basic functionality for connection handling, and it was connection to the base station, from the base station to the network, connection between client device and the base station, and also handling of the client connection. So all these functionalities were implemented in our team with success. It's also required from us the features related to the new 5G interfaces, like NG-XN or E1, and establishment of these interfaces. Also we need to implement self-setup procedures. So it was a lot of work for our engineers, but we had for this work 2 years. So quite big, quite long time. Okay, so as part of handling of the client connection, the features related to the radio admission control and PDU session setup functionalities also were required and were implemented in our team. But as probably you know, all features related to the 5G based on 3GPP specification, but and most of them are similar to 4G, I think, for LTE. But we have some quite totally new functionality, like totally new state in 5G technology. RRC inactive. I think that it's the biggest difference between LTE and 5G networks, that we have new RRC state. So this new state was provided to reduce cost. I think that not only energy cost, but also it reduced signaling load and something like that. So it was important to us to keep this feature in our team and implement it. Yeah, maybe to some of the benefits we have, of course, reducing energy consumption in our mobiles. We can optimizing the use of radio resources, and also we can in efficient way use machine-to-machine systems and of course, in consequence, IoT systems. The second quite big functionality was high availability. And what does it mean exactly? It means that in the case of component failure, the mechanism that monitors the components totally transparently to our user will switch to the connection to the spare component. So in order to maintain data continuity, we also, when we're switching between the components, we store our data in SDL, shared data layer. So it's also our product. And this feature increases, of course, the stability of the internet connection in our 5G system. Oh, sorry. Yeah. I think that later I will show you the exact results of this implementation. Like I said at the beginning, we also working on hardware part. We have some hardware systems in our TC in Wrocław, but also in the Krakow. So for this specific research project, we use a UE simulator. We use some system modules like AirSky airframe and also airframe switch and radio modules. Here in Wrocław, we had 2 test lines for entity testing for clouds. We also have 4 test lines dedicated to basic call for our project also. Here you can see the UE simulator on the left side. It's COPHAM. So it is connected to the outgoing signal from the radio. And also on the right side, you can see the radio module configuration of this module. Allows us to test end-to-end our solution in end-to-end way with this UE simulator. And still, all of this hardware is in our TC in Wrocław. Here we can see also IMF simulator on airframe here, and our DU on AirSky system module. And like I said, we have also some baseband modules from Krakow, and also here you can see radio spectrum signal analyzer. After implementation of our features and after testing of this technology, we can sum up some project results in our team. So thanks to our research and provided technical solution in software and also hardware, we achieved some record in November 2020. The measured data transfer rate between the base station and the 5G phone was 8 gigabits per second. So when it was recorded. Later I have some press report on this topic, so I have some evidence that it happens. So the second result is reduction of transmission delays. So we achieve it thanks to the significant minimization of delays in our 5G mobile networks, because we use a solution in application and system requiring real-time response, and it is possible. This will allow us to the rapid and dynamic development of such industries, autonomous transport and logistics. It's quite a general result, but here the more interesting is that we we can use new radio bands. It was 38 gigahertz, not 28 like I said at the beginning, in our mobile 5G system. So it was our goal, and it's quite good that we can achieve it. And also the last two results are related to our new innovative features, high availability, and also RRC in active state. So for high availability, we in our 5G team, we implemented we duplicate 4 components of the C-plane software. It was for CP-cell, CPUE, CPIF, and CPNB. So it allows us to significant reduction of the connection failure rate. So it's a big success, I think. And also we implemented the state change mechanism. For example, to change the state from the RRC idle to connected, or connected to idle, and also from connected to inactive state, and from the inactive to idle. So it was, these functionalities were implemented also during this time where our project was conducted. So yes, here we have some evidence from press reports. But I think that you can also see that it's Nokia reports. But here we have some values that in Turkey we achieved 4.5 gigabits per second 5G speed. So it was quite good results, but the record was 8 gigabits per second in Finland in 2020. Yeah. Oh, and that's all. Thank you for your attention. If you have any question, please ask. I will try to explain. And I think that I would like to encourage you to maybe when you work at Nokia or other telecommunication company, that you may think in other way, that we also can do some research, some study in our firma, not in our company, not only our daily work with a small part of software, where I think that in many cases developers don't even know what exactly implement in the general overview. But we have a lot of opportunities and also research grants. It wasn't only one research grant in our team. We have also grant for IoT systems, so it's quite a popular way to receiving funds for Nokia. Thanks.
Do you have any questions? Please raise your hand if yes. If no, okay. Thank you, Marta.
Thanks.
Thank you once again. We have a gift for you.
Oh.
Okay. Thank you. You can sit down. Okay, dear audience, this was our last lecture. So thank you very much for the whole day which we spent together. For now, I would like to invite you to the closing ceremony, and also there will be awards ceremony from our tournament. It all will be happening in the room number 1, and it starts 6:15, I guess, but please check it on your schedule because my memory is fading right now. Okay, thank you very much. See you in room number 1. Thank you.